Test. Can you guys hear me? Oh yeah, you can. So yeah, welcome everyone to AuraNova event, and thanks you all for being here in this snowy day. And we're thrilled to have you all to join us and as we explore the exciting worlds of decentralized science. And thank you for being here and being part of this journey. And I'm Eva from AuraSign and also Paramita. And also thank you to joining us today. And can I switch to the PowerPoint? Sorry. Yeah. Yeah. So today I would like to share a story of discovery, connection, and creation. This story about design, about me, about us, and about why we founded AuraSign. So my journey began with serendipitous when I stepped into a design meetup, which introduced me to the concept of design. As a former Web3 participant with the background in mathematics, and I was immediately attracted by the vision and potential of designs. As I dive deeper, I realized that design offers a unique opportunity to combine the scientific research with the blockchain technology and making the research process more transparent, co-censorship resistant, and collaborative, thereby providing more opportunities for the younger generation scientists. And our mission is to fully understand So our mission is to fully understand design and bring together diverse forces and breaking down the barriers of knowledge and ideology and leveraging our experience in both online and offline human gatherings. We aim to help the design community form cohesive narrative and present them to the public. And in this field, we see challenges and opportunities, feel a sense of belonging and more motivated to contribute, which is why we're establishing the AuraSign. We do not confine ourselves to be a specific definition, be it at a community, media, or otherwise. Our goal, mission, and role are to gathering different voices in design to drive the scientific process and society movement. And our vision is to gradually expand our influence, starting from building a vibrant community to address accessibility issue in scientific research and ultimately establishing an ideal community. And we believe that by providing a platform for truly remarkable individuals to communicate, inspire, and to create ideas is fully emerged in a unified decentralized science space. And forming that something larger and greater and more constructive and more instrumental for the construction of design infrastructure and framework setting. And the choice of AuraSign as our name because it reflects our belief in the combination of humanistic spirit and scientific innovation. We hope that AuraSign can serve as a bridge connecting individuals with the science and discovering each person's unique inner worlds, while the deeply understanding and participate in the world of science. Like the aura of humanity, we hope that AuraSign can be a platform that connects humanity with the science and individual with the cosmic energy. And we believe that through this connection, we can reveal each person's unique inner world and force a harmonious consensus between the individual and science. We believe that the future development will be the combination of humanistic experience and scientific innovation, with humanism as our lighthouse and science as our boat to crossing the river. Through the AuraSign, we hope not only to dismantle the knowledge, but also to become a connector between different fields and exploring new frontier of science and technology together and bring more an open and inclusive future. And as part of Parameta, I'm both excited and proud to introduce ourselves. And Parameta is a thesis-driven investment group and focusing on public protocols. The key thesis is to intersubjective trust minimization, which including decentralized information, decentralized science, decentralized society, and for a better future, network future. And we valued public scientific research and infrastructures. Parameta stand out as it not only drives the shift towards science-based economics through liquidity, but also accelerate the project with the research support by the community. In addition, the aids in the development of public goods and collaboratively shape the narratives and ecosystem. And in the design domain, we have already some partners and portfolios such as VitaDAO, Vitalia, Data Lake, and also Design World. So we hope to involve more in design field. And so if you knew any projects or your project is currently for a fundraising, please feel free to contact us. And the journey of our scientists here will be a vibrant and explorative one. So there's our journey. So from the January, our core member visited the Vitalia city, which we met design friends from different regions, fields, and also opening up a perspective and collaborative opportunities. And in the February, the AuraNova events in Denver and the social party on the 28th is our first offline gathering, an exciting moment to face-to-face exchange and sharing the passion and also vision for design. And in the March, where we will renew at the Design London event, and another fantastic opportunities to dive into the latest development and future trends of design. And in the mid of April, we continue our design journey in Boston, looking forward to meet more like-minded friends and also exploring new frontiers in science and also technologies. At the end of April, our event will host in Dubai. So we are hosting and offering a fresh experience for the design people. So in the future, our footstep will expand to Europe, Singapore, and Thailand, and beyond. Our goal is to extend our science influence and also design influence globally, and promoting the growth and prosperity of design movement. So all in all, I invite you and everyone in here, and regardless of your background or your location, to join us if you are passionate about design. And we are looking forward to bring more core members on board for the AuraSign. So if you are looking forward to join us, please contact me or scan the QR code to join our community. And also I attached some QR code like website, Twitter over here. And thank you all for joining us today. And yeah, my talk is finished. And also, Erin, you're here, right? So welcome Erin for the Design 101 and Landscape.
Hello, everyone. Super excited to be hanging out and chatting on DSci with all of you. I know there are some DSci OGs in the audience right now, so good to see you all. Some of this beginning will definitely be familiar, so if you are already deep into DSci and this might be a bit kind of common knowledge for you, maybe thinking about it from the angle of, oh, we've grown this far, what might we need to do to take this whole ecosystem to that next level? and what different opportunities might we be able to coordinate more effectively to achieve this next step as we go from DeSci 0, DeSci 1, DeSci 101 basics into a more robust ecosystem. So when I think about DeSci, I really see it the same way that the internet was a platform that allowed all of these incredible technologies to kind of blossom up and grow from it. Same thing with Web3, all these different protocols and dApps have been able to blossom on top of that. DeSci is doing that same type of thing for the scientific and decentralized science ecosystem. And this is really kind of leading off of some opportunities in science, which many of us are familiar with, having a bit of that academic background, noticing that exodus of medical providers and postdocs. But as we're working in this DeSci ecosystem, maybe really thinking about how can we create more inviting opportunities or just kind of outreaching for all of these talented people to come into this system and really integrate with the technology that's being built out to keep building this landscape moving forward. Similarly, patients and people want to be part of these conversations as well, so how are we designing with that in mind? Just the increase in tech adoption and appetite, kind of extending that into developers and just inviting them into that equation. And then allowing scientific discovery to actually have some of that real-world impact and translation into actual kind of impact in the world. And ultimately, this is building towards what DeSci is. This is one definition from what has been posted on the Ethereum Foundation website. But this is a constantly dynamic and evolving definition that we're all able to create and continue contributing to. And for me, it's really kind of this alignment of each of these different parties that I briefly mentioned on the previous slide, and aligning those different incentives and designing both that foundational infrastructure as well as social infrastructure to be able to achieve that effectively, as well as financial. Brief background on me, I've been working in DeSci for a couple of years now. Original background in neuroscience, then got into tech startups, so definitely am able to kind of come into this conversation wearing a couple of those hats, as I think many of us have as well. And I'm really passionate about what a lot of the orgs in this space are doing to really push this forward. I've been able to work with a good number of them as well, and I'm currently focused on building out a DeSci fellowship program to just expand the number of projects as well as talented people coming into and continuing to really root down in the DeSci kind of opportunities here. Ultimately, for those of us that have been in DeSci for a little bit, I think it's really fun to be able to look back at, like, not even 2 years ago. This is where it began with, like, community platforms being Telegram as a whole and Discord as a whole, and now we have more refined tooling for that, and looking towards the future over the next couple of years, what might this look like as we begin to kind of take those further steps forward and maturing. I was having a really fun conversation with a few people 2 days ago, and they were saying, yeah, DeSci isn't a baby anymore. It's a bit more like a toddler. And I really enjoy kind of that mental model of, yeah, we're still young, but we're starting to take those steps. And from May 2022 to October 22, like growing up a little bit and defining some of these features. And then moving into August eventually, it got more refined, and it's continuing to get more refined. And one kind of trend I've noticed as this refinement has been happening is that DeSci has followed a lot of the broader Web3 trends of some of the different orgs that kind of laid their roots, followed what was happening in the broader conversation, whether it was ICOs or NFTs and DAOs, and really kind of leaning into that narrative and being able to take those benefits and apply them to science. And as we kind of move into this next upswing of crypto markets, just thinking about different opportunities that might be had here as part of the broader conversations happening, whether that's from like a more deep-in and hardware type side of things or social, as well as just larger data plays as well. And we've definitely explored some of this from the DeSci landscape analysis. So one of the orgs I've been involved with is the DeSci research team, DeSci landscape analysis, really mapping out the ecosystem. We have a second survey out right now, so if you're part of an org, really contributing back into the ecosystem of what you're working on allows each of us to refine further and collaborate more effectively. But in this landscape analysis, we kind of identified a few different focus areas of different orgs in the DeSci space, and we were primarily focused on the Gitcoin public goods cluster of DeSci, which is generally what a lot of us might refer to when we think about the DeSci ecosystem. But there's also kind of a broader conversation happening more in what we might generally refer to as Web 2 startups, or taking a bit more of a focus on those traditional institutional type plays in the scientific space and the opportunities that are available there, as well as much greater lumps of funding that can really allow these narratives to be able to be built out, and a good handful of orgs playing kind of in that middle ground as well. And as we were thinking about building continuously in DeSci, I think it can be helpful to recognize the larger ecosystem that we're a part of and the different collaboration opportunities available there that might support us in having that bigger impact that we see in just improving and changing science. And in this, there's a lot of really incredible focus areas, one of which being publications or technical infrastructure. Another primary category that a lot of DeSci orgs are focused on is community building, funding, and research. Those were kind of the 4 clusters of DeSci focuses right now. But there are a lot of needs to be able to continue building this out effectively, as well as within each of those categories, a lot of different ways to approach technical infrastructure, for instance. And within this, still 54% or half of the orgs need help on that talent attraction side. So as this landscape continues to evolve, just thinking about the narratives each one of us are playing in that whole equation. So that last slide and some of these different trends I've commented on has come out of the DeSci research team, and it's really oriented towards advancing overall DeSci ecosystem knowledge. If you are part of a DeSci org, please go take survey number 2, which is out right now. We'll produce a similar report to number 1. And this ultimately is also knowledge pushed out to different funding opportunities across the entire industry, kind of being able to uplift everyone. And like I mentioned, one of the biggest findings from that is talent attraction is a challenge or an opportunity here as well. And so within that opportunity is kind of the space to be able to cross-pollinate ideas across different people, which is why these in-person gatherings across tech and science are so important. Really focusing on building that interoperable and more resilient infrastructure, which can happen through these conversations too, just creating that alignment and coordination, and then ultimately working towards upskilling and funneling this talent into the ecosystem. And And that's where Muse Matrix comes in. It's a DeSci fellowship launching in Q2 of this year, with the primary goals of upskilling people both on the technical side as well as the scientific side to build out some of this core infrastructure. So if there are different needs that you're noticing, I'd love to have a conversation on what needs to be built out there, just so we can kind of place that as opportunities in front of these fellows. And then if those projects are VC kind of backable or applicable, aligning on that front, or funneling that talent into all the other incredible orgs here. So yeah, if that sounds of interest, definitely apply, join as a mentor, or just be part of our organizational matrix. Or if you're interested in investing in some of this infrastructure, we can align on some of those project opportunities too. This is half in-person, half remote globally, and building off of the DeSci London community, which is over 600 people. So really kind of also exploring what does the future of decentralized scientific work look like, and how do those needs vary in different regions around the world as DeSci continues to be built out effectively. So I hope this conversation just gave a moment of pause to think about what DeSci opportunities you might be able to see, or maybe somebody you know who might have a different angle to approaching what DeSci could look like. And I would love to continue this conversation, and I think we'll have a bunch of incredible presentations later today diving into what it looks like right now and what it might look like in the future too. So with that, would love to connect, and thank you so much for sharing your time and interest in DeSci with me.
So next we'll have the first panel, but we'll start at 2:35. So guys, please feel to take a break, and we'll come back at 2:35 for the the revolution of open access publishing with the blockchain. Hi guys. So we're having the panel right now. So welcoming our speakers to on stage. And yes, I'll pass the mic to Jeff. She's our core member of our sign.
Hi everyone, welcome to the panel one, and let's welcome our dear panelists to be on the stage. I think it's Eric and Jonathan, right? And also Taylor. Who's Taylor? Sorry. Oh, hi Taylor. And we also have the Danny, right? Okay.
Testing.
Yeah, actually, Eva told me that Danny from Research Hub is still on his way, so we can maybe start first. And so this is not like a very formal panel. It's like a friend conversation-ish, fireside chat panel, because I saw that some people here really deep into DeSci, so we can just skip the to the general public questions and to dive deeper into each project. Okay, so maybe we can introduce first. So for me, I'm like core contributor at AuraSci, and I think Eva has gave us a comprehensive overview of what AuraSci is doing, and so I'll leave the stage for the other panelists to introduce their project. Yeah.
Cool. Well, I'll start just left to right. Okay. My name's Taylor. I like to fashion myself as a bit of a nobody. I got my start doing mostly DeFi-related things in 2018, mostly with automated market makers. But for one thing or another, I figured about a year ago to get involved deeply in the DeSci space, doing a bit of open source work for projects like DeSci Labs, and eventually getting a job at Molecule doing their smart contract work about a month ago.
Hi, I'm Jonathan Kang. I have a background in brain-machine interfaces, and I dropped out of grad school to start a science publishing DAO. Don't know if it's a good idea yet or not. So.
Sure, and my name is Eric Winkle. I work for DeSci Labs, doing a lot of our business development with a focus on fair data, research, software engineering, and institutional adoption, so more the research data management space. My background is in mechanical engineering, and I'm happy to be here speaking to you guys. I think this will be a great panel.
Yeah. So would you mind introducing yourself?
Yeah. Hi, everyone. Hi, everyone. I work for Research Hub. I work for the foundation. I'm the head of partnerships there. I can tell you, are we talking about what our organizations do or just what we do?
Introduction.
Oh, introduction. Brief introduction. Yeah, so Research Hub, my name is Edwin. My name is Edwin. I've worked for Research Hub, the foundation, for a couple of years now, and we're just trying to build scientific infrastructure that incentivizes a range of what we think are actions that are productive for the scientific commons using a range of incentives.
Yeah, thanks for the introduction. And I think I'll start with the general questions first, and then to dive deeper into each project. So first, what do you think, how is the blockchain technology transforming the landscape of open access publishing? And what was it before, and how could blockchain technology enable it to be more open access in the future? Yeah. Starting maybe you?
Okay, I think this works now.
Yeah, nice.
Yeah, so for us, we're not, I think DeSci Labs is doing more stuff on the protocol layer. What we're using primarily with blockchain is just tokenization. We think, a lot of open access publishing, there's just not, there aren't financial incentives to do so. And there's also not financial incentives to engage with the published materials. and when you have financial incentives, you can also build reputational incentives. So in terms of how we're using blockchains, it's primarily tokenization of the value that's created on our platform.
Yeah, I like to think as blockchain as a sort of middle ground between the Guerrilla Open Access Manifesto of Aaron Swartz and the Reed Elsevers of the world. On one hand, right, we have the vast dissemination of knowledge in a very anarchist manner. While on the other hand, like if you want to access one paper, we might not even cite we have to pay north of $90. And in the global south, for example, when you're living on $1 a day, like we can't really ask the next generation of scientists to save up for 3 months to read a sort of paper. So hopefully, by adding a smidgen of financial incentives and being able to incorporate those reputation layers, we'll be able to drastically bring down the price, hopefully to cents, at least to access those papers.
Yeah, well, I think this is it's a very interesting question because so far we haven't actually moved the needle at all. The problems of science are mainly social, and I think the reason why people got into DeSci in the first place, or the biggest problems of science to begin with, is the over-neoliberalization of the academy. So basically you have universities and big publishing being big business and monetizing prestige. That's pretty much like a very large source of all the problems. So we talked about reputation, how do we actually layer that on and build that into, for example, scientific publishing, for example, whether we're recreating, PIDs and, different research units or whatever. But I think it's really trying to connect the social and the technical in a way where, for example, when you have more business and legal savvy people entering the space, they can't actually use this technology to actually put us into a worse situation than we currently are. I mean, there is a reason why scientists have somehow signed up for the worst business deal of the century, right? So we need to somehow focus on, we're great at, focusing on the tooling, but, let's not put the cart before the horse because we're better at engineering carts. So.
Best cart you've ever seen.
Yeah.
So, if it's okay, I might expand the scope of the question a little bit. From how does blockchain help open science to how does the decentralized web help open science? It's good to start with the framework. One of my favorites is the theory of change from the Center of Open Science. So it's a blog post by Brian Mosen that basically says if you want to see change in academia, you need to see change across 5 different levels happening simultaneously. It's infrastructure, applications, communities, incentives, and policies. And that a huge part of the reason why we haven't necessarily seen the change that we wanted to see from movements like open science, for example, is because they really targeted communities and incentives as 2 individual pieces in the larger stack of science itself. But there wasn't the same focus on applications and infrastructure. And that's a challenge in and of itself. So then, after open science, one of the next movements that we see come along is the fair data movement, which builds on the ideas of open science, but is targeted more at the infrastructure layer. So how do we handle persistent identifier technology? What does the next generation of repository sciences look like? They are good back-end engineers, but there's still opportunity in the application space itself. So the pyramid is structured, infrastructure, applications, community. To me, DeSci is the linkage between infrastructure and community through the application layer, but tying each of those together. And part of it is product development, part of it is protocol development, some of the work on the back end. But whenever you think about the decentralized web, there is a certain element of trustlessness that is required. There's a natural decentralization which mirrors the organizational landscape of academia itself. So one of the biggest challenges in science right now is how to facilitate collaboration across organizational boundaries. means to work with an individual researcher in a lab at a university. Well, in order for them to effectively collaborate, you're going back and forth between organizations, and that means transferring data back and forth. That means emails across organizational boundaries in a landscape where it's mostly trusted institutions. So I think where the decentralized web can help is in a lot of the application layer through product development, and then in a lot of the protocol layer facilitating connections and collaborations across organizational boundaries.
Yeah, that's actually very well said, because we talked about earlier about this like blockchain technology or decentralized web. And actually for me, I think the core of blockchain technology is to coordinate the incentives of different participants. But for now, when you're like referring to crypto, people also think about like financialization, the Ponzi games, and all this. So my next question is actually for you two, because you mentioned that Research Hub is kind of using the tokenization to solve that science publishing problems and to get more like people included in this process. And also for Taylor, because you're kind of like transitioning from a DeFi background to paying more attention to DeSci, so you might know more about like the incentives alignment behind the financialized applications as well. So how can DeSci kind of borrow some insights from that as well? So yeah.
Yeah, so I'll start. So the way we're thinking about it is we want to sort of mirror the incentive systems that currently exist. I mean, there's a lot in terms of, data sharing and a lot of what you guys are building, but we want to start simply mirroring incentives that currently exist. And if you think about a lot of what scientific research, like what progressing a career in science entails, it is about increasing your access to funding to do the kind of research that you want to do over the long term. So we have incentives to do things like peer reviews or just engaging with papers in a public way, and the range of actions, getting questions answered for bounties in ResearchCoin, range of actions that we think are good for the scientific commons. But we sort of tie it all in such that engaging in these actions over time allows you to increase your chances of getting funding, right? And the good thing about crowdsourced funding infrastructure, number one, a lot of people on the platform can actually like give resources to specific experiments, but also people who are interested in different kinds of funding, either for intellectual property or for philanthropic reasons, are also free to use our infrastructure to fund research. So we're building tools that we think allow people to not just publish better, but start the entire stack, right, from the experiments themselves all the way through publication, doing it in an open fashion, but also that allowing people to increase their ability to raise capital to do the kind of research that they want to do.
In terms of developing games, I look at finance as primarily an exercise in game theory. And when we talk about bringing games to scientists that help them accomplish their objectives, whether it being access to equipment. Right now, a good proportion of university lab equipment, for example, goes unutilized. And if we found a way and to provide incentives, for example, so that they could ship it to one location and then have them ship it to another location, then we can increase the utilization of such equipment. In the world where cash flow is more important than cash itself, we want to start thinking about ways where we can bring cash flow to scientists instead. Technologies like drips over ideas not just like GitHub commits, but additions to the scientific record can provide predictable cash flows to scientists so they can go to a bank and say, hey, I'm not just looking for random grants, but you can now project my cash flows for the next 5 years, drastically opening up access to credit for them. On issues such as crowdfunding, right now, capital access around the world is incredibly heterogeneous. The rules coming out of really capital lax places like Ireland, the Netherlands, the Cayman Islands is drastically different than talk about Mongolia, Zimbabwe, or Argentina. Providing equal access to that capital through blockchain technology can help level the playing field between the global north and the global south, hopefully creating situations where we can start engaging more stakeholders in the scientific process. There's no reason why we can't be asking coffee farmers in South America to do analysis on soil samples. We don't need to be sending people from North America to go do that sort of thing.
Interesting points. And I know Jonathan is actually doing something different, like from a governance point of view. And we also talked earlier that you're not just focusing on the blockchain side of it, but also other technology as well, like distributed networks and AI as well. Can you briefly elaborate more on the DGF or DGF that you're building, and what are the most insights that you're proud of that you produced and it actually has applicable values?
Right. Well, first of all, I think the conversation starts with how do you bridge the social and the technical, right? And we keep talking about code is law and such, but at the same time, that's really static. And ultimately what we want is we actually want the spirit of the law to basically be aptly implemented with an ever-changing situational landscape, right? So the code of the law should actually change with the spirit of the law, because that's actually what we care about. But the blockchain is so rigid, and so part of what we've been exploring at DGF is basically how do you make this thing evolutionary? How do you make this thing adaptive to the situation? So it's not just like, okay, here's the super rigid set of rules that, we all know that if you have one set of, rules, that it becomes fairly gameable over time. So how do you actually build a lot of resilience by looking at a lot of these social problems that have plagued a lot of communities over time? So, and then also, so DAOs in general, they are, how do you make this thing sustainable, right? Like decentralized organizations have existed for a very long time. I don't actually think a DAO exists yet, personally. We have had very poor implementations of this automatic part into this more fluid situation that we have hopes. But so that's kind of like our research. We've been bridging that to actually how do you maintain a healthy, sustainable forum over time amidst all the emerging tech. Right. Specifically at the moment, it's just like we have blockchain, there are other distributed ledger systems, there's AI. How do you actually, assuming that's ubiquitous, how do you still have a conversation over the internet without getting disoriented immediately, right? So that's kind of how we've been going about things. Let's see here, some insights other than. Right. So I guess to summarize, spirit of the law is more important than the letter of the law. And then how do you actually get around the Goodhart's law and Condorcet's theorem, which basically state that there's no voting system that will consistently elicit the wisdom of the crowd and its experts, as well as there's no single rule set that will not be gamed over time, especially if you have assets and value and stake in the game. So basically, our whole system is about how to make all of that work.
Please make it work.
How to make the collaboration actually happen in the space, yeah. And for Eric, I actually have a question for you. So how did you, how did Design Labs find out the angle that they're positioning themselves right now to enter into the design as an industry? Yeah.
How did we find the way to enter into design now?
Yeah. So for example, that so for example, Research Hub and Taylor, they are kind of looking at the problem as a like from the tokenization point of view, and Jonathan is like practicing it from a governance point of view. So how does like DeSci Labs take this kind of lab point of view into this field? Yeah.
Gotcha. Okay. So I think it was, oh Lord, it was like 3 or 4 years ago at this point, where essentially it was a group of people who were passionate about bringing reproducibility onto the scientific record, who saw some of the problems about the replication crisis coming up. I think one of the co-founders, Philip, is a genomics researcher by trade, and one of his earliest projects was actually working on aggregating data in the early 2000s to basically prove another study false, because results had come out that seemed too good to be true. The general public was acting, and by acting I mean actively mutilating themselves at scale based on scientific findings. And he was able to aggregate, I think the standard at that time was like 5,000 data points, and he brought together like 250,000 by organizing a consortium of, I don't even know, it was like 70 different research institutions to prove that this information was indeed false, and it was just a small sample size. So from that, eventually the genomics field came together and said, y'all, I think we have a problem. And from there, we've actually seen very high quality data management in the field ever since, where you've now got projects like the UK Biobank and others who are large-scale repositories to help organize information. So I think that that passion for reproducibility and the replicability of results eventually led to the question on the team of, how do we stop the replication crisis? How do we use emerging technologies to make this better? So locked ourselves in a room for, it was like 8 months, and tried to figure it out, and went through every possible combination we could think of. Eventually came to the idea of research objects, tried to do that through traditional infrastructure, realized that that wouldn't work, dove into the infrastructure and figured out what needed to change. And that was, I think, kind of the starting point there. So that was a while ago, and ever since it's been, okay, we have these research objects, we have scalable persistence, we've made the changes that we think need to be made in the infrastructure. Now, what's the killer use case to get people to actually care about reproducibility and replicability?
Yeah, I actually would love to hear everyone's story about how you kind of overcome the biggest challenges along the way. So basically like when you were kind of digging into this project from digging into like DeSci to solve that specific problem that your project's solving, what are the biggest challenges you've overcome, and can you describe it? Yeah.
Well, I can't because I'm not a founder. So I work with the organization, but I couldn't answer that question.
Got it.
It's a tough one for me to answer too. I suppose the journey into DeSci, the hardest thing to overcome, I think, would be the social-cultural shift in the space. I just feel like we're building really high knowledge spires, and those just thrust a really high degree of moral hazard on individuals at the top of the spire. And I think at some point, in order to grow higher, we got to grow wider. And so trying to find those places, DeSci was one of them, where there stands to be a potential to grow out the base a bit more. I think that's where the biggest challenge is, and that is the kind of biggest challenge to overcome, at least for me.
I would say I would say interface with people that are not familiar with blockchain and its potential. Especially with DeSci, I think it has a slightly different message than DeFi, but pretty much when you say blockchain, they immediately think like Bored Apes, and and so it's like no. It's like it's I don't know. It's like you're already caught in a box. Once you're saying it's not that, right? So it's and then there's also the UI problem. And then at the same time, so I've talked to, maybe like a few hundred scientists and librarians and university administrators like last year, and like no one knew. So no one knows, and if they do know, they think it's gross. And then the UI is a problem as well. So
I've definitely had people think the entire thing's a scam. So
yeah, the only thing, like, the trusted institutions produce the best results.
If you just feel like people fear what they don't understand, and you can have Sauron in his dark spire yelling to his armies, but after those armies are done pillaging the hinterland, what are they going to go for next?
And they also fear how other people perceive them if they recommend something that is unfamiliar, whether or not it's a scam.
And so I can only really speak from the business development standpoint. It's figuring out the things that people want to hear. Because ultimately, nobody cares about blockchain. If it runs on blockchain, if it doesn't run on blockchain, I'm not using Netflix because it's powered by AWS. I'm using Netflix because I want to watch a movie. So I think it's, at least from a business development standpoint, kind of piecing together the things that people need, the problems that they have, and the ways that blockchain can or can't solve that. Because blockchain is a very specialized technology, and the decentralized web in general is a very specialized technology with very specialized use cases. And there are times whenever the use case just isn't the right fit for the technology, and that's okay. But I think it's been a journey, first off, finding terminology that hits, and then realizing, oh shit, I've got 8 different user groups that I have to talk to. And now I need to find terminology for each of them, and then, oh crap, it's different on geographic regions, and now it's just split into this indelible tree of things that you have to say at any given point. So I mean, that's been a challenge, but it's also been a lot of fun to try and figure out, to empathize with people who have issues and to see if you can help, because for a lot of people, they see the problems in science. They understand that it's not a sustainable system, that the way that we publish and disseminate and validate knowledge right now is not okay, that they don't get the money that they need, and that, the H-index, the impact factor, and prestigious journal submissions are not a good way to identify quality. But it's a question of where do you go and how do you get there, and that's a very difficult question.
And sorry, one more thing. And when you're talking about incentivization with tokens, there's also concerns about it being a scam, but there's also just the economics of early stage tokens, the fact that they're highly speculative, the fact that they're volatile. For a lot of us, we've been around crypto cycles, so we sort of understand liquidity cycles and how to think about these assets. But for a lot of people, they don't, and that level of volatility is very uncomfortable. So actually getting them to value the incentive structure to some extent means them understanding the economics of the crypto sector, and that takes time to explain, and it's kind of difficult. So.
Yeah, I totally agree with you on that, because every time when you explaining incentivization with blockchain, then it'll become a speculation or something.
And academics hate speculation.
Yeah, and yes, 100% agree with that. Yeah, and I'm kind of I'm actually agree with Eric's point on I'm watching Netflix because I want to watch the content, right? So what do you guys think the most killer user scenario that this can be applied to? Because for now we have content distribution problem, we have the peer review problem, and we also have the IP problem. So there are so many problems that this decentralized science approach could kind of include in that solution set, right? But what are the killer case that we might drive the first adoption?
So if I can start off with this one of the most amazing things to me about this community is that it is a small, tight-knit community of brilliant people coming at different approaches to the exact same set of problems. And that ultimately it's probably not any one solution that works. It's a clever combination of all of them. where all of a sudden, let's say data is published through DeSci nodes. Eventually, it's in its final state, it's kept encrypted, turned into an IP NFT, which is then published on Research Hub, and people can comment and use that as a community validation layer, all with an interoperability layer underneath, connecting these three projects seamlessly. Because I think that the killer use case, at least from a tooling standpoint, that we don't have in the traditional academic system is connectivity between applications and organizations. It's a series of silos, and that makes everything so incredibly difficult.
Oh, yeah, sure. Thanks. So I have three things. Hopefully I can keep them all in mind. But the first one is, so we have this idea of an ecosystem launch, right? There are lots of great things about the DeSci community, like Eric has said, but at the same time, it's like we're this decentralized network, and we're trying to. I think there are a lot of founders here that are still kind of maybe taking on some of the habits of startup world, where it's very centralized, and we have to have some sort of ROI. We have to protect all our IP and all that and such, but we need to dog food our own work more, right? So we need to collaborate more in the ways, and then we need to dog food our own technologies more in the way that because we're trying to pitch to the larger scientific community that hey, look, this is a better way of being, this is a better way of doing things. And unless we actually dog food a lot of our own products and also collaborate in the way that we hope the future of science is going to perform, we're actually shooting ourselves in the foot for long-term impact. So on top of that, I forgot the other two. I knew I was going to forget.
And go back after you.
Well, on both of those points, from what I've seen on the space especially, is that I know I come from the tokenomics side, but I don't see the problem as economic, more so as social-cultural. In order to start dog fooding all our work, it'd be really nice to hide all of our great projects in tools starting at the high school or undergraduate level, to really kind of start breaking the mold. Imagine instead of a resume you have to order from your university and you've already forgot your email, you have a GitHub day by day with your popes, with peer-to-peer attestations that you can go to your supervisor, you can go to an employer, you could go to anybody. And once, because even in the books of old, right, it's they would all preface their work with a homage to the king. When kind of breaking out the normative molds of science and where we're supposed to go with, as Tesla said, the man-made horrors beyond imagination, showing that it's okay to go peer-to-peer. It's okay to mix peer-to-peer with superior attestations. Then we can start seeing some exploration in the DeSci world. And if it's hidden behind their projects in the learning phase, I just see it opening up so many more doors 5 or 10 years down the line.
Yeah, so in terms of the killer use case, I think the question you asked was what's the one thing that could spur adoption?
Yes, it's the most, maybe the first adoption.
Yeah, so I think that's funding. Yeah, I think funding is hard enough in the scientific world that if you can make it easy for people to fund their experiments, that can go a long way to get people to start using these new networks.
Cool. Yeah, so I actually listening to all you guys talk, I was thinking of modularity and the tools to solve the interoperability problems between different parties. In blockchain, we also talk about this all the time, right? So, and modular stack is actually one of the hottest topics right now. In DeSci, we also have that kind of modular stack. So, for example, for the publishing, we can use a research hub and and also for the governance, we can use DGF and all this. So, I think my next question is about so let's ask about this way. So how do you see the open source publishing or like design in general in like, let's see, the next 3 to 5 years? Like to which direction it will be like evolving, and what are the like verticals that you are paying most attention to that you think will kind of emerge? Yeah.
Somebody else try to answer this question first.
About the future.
Yeah, I can take this. I'll throw 3 of them out there. For starters, AI. Everything around semantic publishing and the idea that we can aggregate knowledge around concepts based off the raw information collected is going to be a huge point. And I think the DeSci space and the general Web3 space is actually really well positioned to help with that. And it goes beyond vectorized embeddings on text-based artifacts. I think it goes into code, data, well, I guess code you can still do a vector, but that's fine. Code, data, et cetera, et cetera. So it's how do we think about vector and semantic space. I think the second thing that I would say on that is pluralism and community validation. I think that's another huge point that we're going to go towards. Because one of the impossible problems of the internet is how do you have an open network that doesn't just immediately turn into cat pics? And that's a problem. I mean, it's unfortunate, but this kind of moderation in a fair and transparent manner is definitely an interesting point to go off of there. And then I think the third point, once again, to hammer it home, interoperability. So it's the idea that information can be modular across different parts of the stack and transfer seamlessly between organizations. Those would be my 3.
Yeah, I would be highly reflective on that, and to like trying to make it more clearer, I would say in an LLM model you can provide context. So we see the modularization of context. You'll be able to pull multiple streams to be able to basically bias your query to an LLM. And so you'll have the context provided by many different individuals, basically at the click of a button, to get the fine-tuned model that you desire to answer almost any question.
Yeah, again, I think Eric covered a lot of the major points in terms of community and certain kinds of technology integration. AI is the big one, but I think also, positioning, understanding that AI is effectively, especially with LLMs, are effectively intellectual tarot. So it's having to contextualize that and build the proper review infrastructures so that it doesn't just spin us out into a million different options that get us nowhere. And then community-wise, I think it goes back to the point that I was making before. It's like we actually need to dog food our own creations at the moment as a community. Otherwise, we won't be taken seriously. And at the same time, knowing that Elsevier is going to outlive these economic downturns, right? And it's not guaranteed that we and it would be real crappy if we don't kind of band together and figure out something that they basically buy the entire ecosystem for $15 million wholesale, like when we're all desperate. So
yeah, so I'm not sure exactly what technological breakthroughs, but what I think is going to happen is certain aspects of our community is just going to become more widely accepted, and people are going to be more comfortable with. So the idea of just being comfortable with crypto economics, people being more comfortable with the volatility after seeing people do really well engaging with these projects in spite of the volatility. I think a lot of that is going to happen over the next 5 years, and I think that itself is going to increase the amount of participants in the space more broadly.
Okay, cool. I think my last question is, because we talk a lot about how blockchain technology drives science world forward, right? So what about the other way around? So how DeSci can help blockchain as a technology to enter into like everyone's life and help drive the adoption for the technology itself?
How DeSci can accelerate the adoption of blockchain technology?
Yeah, because it's like a use case of it. And if that use case, so for example, like payment is like a cross-border payment, could be like a use case of like blockchain. So it could be like one day like everyone is using blockchain-powered apps like for payment, but they've already like been adopting the blockchain, right? But they're not like unaware of it. Yeah, I'm like thinking of like the other way around. Yes.
Yeah. So I mean, the way I see it, I think that, like I said, I think funding is essentially going to be the first killer app, just because people need money to do research, and I think once that infrastructure is set in place, and a lot of the things everybody else is talking about on this stage becomes more possible, just because people are using those networks, right? It just kind of can go deeper from that point. So I think just academics being used to using Uniswap, like
it's actually going to happen.
like really simple things like that, and like having strong enough incentives for people to understand how to like do a swap on Uniswap, go to Coinbase, cash your money out. Like there's something really simple, right? Like at Research Hub, we did our alpha test and funded six experiments across the country. And it was not even clear, even though we had the cash, what the process of giving it to those labs would look like. Because there's like regulatory infrastructure that we have to be aware of to make sure that we do things above board. So I feel like just those small details, how we can actually connect to the system that currently exists, I think that's going to go a long way to getting people to actually using the tech stack that we currently have, and what a lot of other people are building. So.
Yeah, for me, it's going to be a two-pronged approach. Coming out that's been gaining in popularity from the blockchain space, I should say, are attestations. The wallet is a very powerful identity tool, and being able to sign an arbitrary piece of information with that wallet is a much cheaper way to go about providing provenance and authenticity of data. So that, in tune with pretty much every piece of tech that we're wearing right now, like I have this watch on my hand that's doing heart rate and biometric data, it's not a stretch of the imagination that this can easily become a citizen science piece, whether you're doing squats for a bodybuilding thing, or you're gauging the average heart rate from a stressful situation, and having that go through your wallet to some sort of fitness DAO that can provide drips or monetary streams simply by you doing what you want to do from day to day. So really bringing this, the scientific endeavor into the background of an individual's day-to-day life, and having the provenance and security and ownership of that data in the process.
Yeah, I would say that this is a problem that DGF has, is trying to solve this idea of basically first of all, like, money doesn't matter if you don't have potatoes, right? So right now you have a bunch of these protocols where it's like these are different ways to very efficiently trade if you had something to trade, right? And some actual terminal utility. And so DGF kind of started with scientific publishing, because scientific publishing is this kind of perfect ecosystem, plus I'm been, baked in that system myself, to solve these problems of how do you actually create a healthy commons? How do you create a healthy knowledge economy? And then once we have that, then we can talk about efficiency, but something has to work, something has to be useful, something has to be valuable first before like all this efficiency actually matters. Otherwise it's just like efficiency to what end? I don't care. You know what I mean? So.
This is one of my favorite questions that I've been waiting for someone to ask for like 2 or 3 years on a panel now. So thank you. Much appreciated. There are so many answers to this. I think, for starters, researchers are brilliant human beings who can have a meaningful impact in shaping the growth of the blockchain space. If you have an impossible problem and you need a solution, you turn to researchers. I mean, that is a huge part. And to add on to that, they also shape policy in a huge way. So by bringing researchers into the decentralized web, by getting them to understand this is a more efficient, this is a more scalable, this is a system that allows you to maintain control over your information instead of giving it to publishers, all of a sudden the narrative in Congress starts to tweak just a little bit. Little by little, it doesn't happen fast, but it happens eventually. To me, that is incredibly powerful. The next point of the 3 I'm going to make is undergraduate degrees. One of the biggest problems that I think faces the blockchain space today is the fact that there are no undergraduate degrees in decentralized web technologies. Every single developer who's made it into the blockchain space has made it because they found it, because they loved it, because they learned it, and because they found a job in it. There is no high school to Web3 pipeline, and a huge part of that is because we're missing the academic link in the middle. So I think a huge part of what we can see by bringing the provosts, by bringing the librarians, by bringing the tenure committees onto the decentralized web is a much more streamlined pathway for developers to come into the decentralized web itself. Then the third point that I'll make, and the final one, is just users. And I think it goes beyond DeSci, it goes beyond DeFi. I love DePIN. If I wasn't in DeSci, I would be in DePIN.
Yeah.
God, I nerd out over that stuff. So like, for example, all of the IoT sensing networks, whenever you combine that with IPFS for identifier creation based on hashes that can be resolved, what that allows you to do is have infrastructure completely disconnected from networking, which is something that a lot of researchers have to deal with on a regular basis. This lab setup I have is out in absolutely the middle of nowhere. How do I store and manage my data to make sure that it's transmitted effectively whenever I get back to a network connection? That's a huge point. We think about some of the compute over data requirements in the health space. Blockchain is so well positioned for that, to do any kind of federated or decentralized compute. I mean, it's a perfect fit. It's just a question of getting them to try out the tools to see if it works, to make sure that it works, because it needs to work. And that's a question of its own. But I think that between those 3 points, the question of researchers researching and influencing policy, high school to PhD pipelines, and users for different segments of the decentralized web, those are 3 huge points right there.
Yeah, thank you very much, all the panelists, for the great panel. And do we have any questions from the audience? Okay, so I think we are concluded here. So we'll have like maybe 3 minutes or 3 to 5 minutes break, and then the next panel will start. Yeah, thank you so much.
Test. So next will be Professor Jialin, and give us several seconds to transfer, and we'll be ready like in 1 or 2 minutes. by the way, we do have the second floor over there, just a sofa, and you guys can chill over upstairs. Please check out, it's really cool. Hi guys, we are having the next lightning talk. So welcome to Jialing, and also he will introduce the He2 protocol. And please grab the seat.
Okay, shall I start? All right, okay. So hi everyone. Today I'm very excited to share with you our He2 protocol. So just a quick introduction. So my name is Jialin. I'm currently an assistant professor at the National University of Singapore, and I'm also one of the co-founders of the Vieta Labs. And then today we're going to introduce one of our recent public protocols, He2. Okay. All right. So if you're building a decentralized applications, so far, there are fairly limited options for you in terms of given infrastructure options for you for consistency and trust in your the options. Right. So here I show you a kind of a spectrum of infrastructures. Right. So on the far left, so you have your traditional TCP/IP stack, things like libp2p. Right? So these are communication protocols. Right? So for these protocols, right? So they are very efficient, right? So in terms of sending messages, right? The message efficiency is really, really high. But the problem is that, right? So they don't give you a lot of good security, right? So at most what you can get is end-to-end encryption, so which can offer you message integrity, authenticity, like signatures. But you don't really get a whole lot more than that. Right? So, but there are a lot of applications that require much stronger security options and security models. Right? So for those applications, usually what they do is they use a blockchain, right? BFT protocol, layer 1, layer 2s. Right? So these framework infrastructure, they offer significantly stronger security. Right? So you can ensure that there is a globally agreed upon, or there's a consensus on a total order of blocks in the system. Right? But the problem with this infrastructure is that so they are pretty slow. Right? They're very costly, and then they don't really scale. Right? So I show you this spectrum. So there are clearly a lot of this middle ground. Right? But unfortunately, so far we don't have a lot of infrastructure options that gave you security or consistency models for this middle ground in the spectrum, right? And then we do realize that there are many applications who can actually benefit from this middle ground trust model or relaxed consistencies. Right? So these are not your traditional Web3 applications, things like Right, so financial applications you usually build on top of Web3. Right, so here we list many type of applications, but this is definitely not a exhaustive list of the applications that can benefit. Right, so there are things like social applications, games, payment and trading, but there are also more recent application categories, things like AI agents, things like cross-chain communication and decentralized physical infrastructure, DPIN. Right? So a interesting property of this type of application is that they are highly interactive. Right? So there are a lot of communication among the different participants in the system. Right? So if you use a blockchain solution for them, right, it doesn't really scale. Right? So you can't really put all your, for example, your social interactions on top of a blockchain if you do on-chain. Right? So clearly it doesn't work. Right? But these applications do definitely benefit from having some kind of security. Right? But unfortunately, these applications, even though we do have these kind of applications for Web3, but their integration with the crypto infrastructure is fairly limited, right? So they're only a small part of their applications are actually leveraging the crypto solutions. Right? So that motivates us to come up with the Hey2 protocol. So Hey2 is a communication layer. So it's a communication system. Right? So you can imagine this is something like a libp2p library. Right? So it offers things like messaging between the different participants in a peer-to-peer system. Right? But it offers a lot more than that. So one of the biggest novelties of Hey2 is that this communication layer actually establishes a trusted ordering among the events in a peer-to-peer, large-scale peer-to-peer system. Right? And I'll tell you later what I mean by this trusted ordering. And then so to establish this trusted event ordering, so we designed a novel logical clock data structure, and we call it verifiable logical clock. Right? So it uses some zero-knowledge proof techniques, but compared to existing zero-knowledge proof solutions, it has a much lower cost and a lot higher scalability. Right? And then by using this kind of trusted event ordering, so we can build various consistency levels and trust models for decentralized applications. So you are no longer constrained to use a traditional blockchain or a solution that doesn't offer any security. So before I introduce the actual Hey2 protocol, let me just give you some background on event ordering, since that's the main focus of the Hey2 protocol. So imagine you have a distributed system, right? And then there are many events happening. These events can be I generate a transaction, or like it's an event saying something like I send you a message and on Messenger, or I post something on a decentralized Twitter. Right? So how do we determine which event happens first and which event happens later? Right? So the easiest way to do this is by giving some physical timestamp or some kind of timestamp to different events. Right? So for example, you can say the event A happens at 10 a.m. and then event B you stamp with a clock of 2 p.m. And then with these clocks, you can clearly identify event A happens before event B. Right? So that's a very easy way to establish event ordering. But unfortunately, this doesn't really work in a distributed system. And then there are two main reasons. So first is slightly more fundamental. So this is due to special and general relativity by Einstein. Right? So in Einstein's relativity theory, right? So if there are relative motion between different objects, so there is this phenomenon called time dilation. That means if the two objects have relative motion between them, then their clocks don't move at the same rate. Right? So for example, if you look at an International Space Station, which is orbiting around the Earth, and then let's say some event happening, or so let's say this venue here, right here. So if you look at the physical clock of these two, on these two different places, their clock doesn't agree. Turns out your clock on the International Space Station runs slower than that here. Although it is pretty small, right? The scale of time dilation is very small, but it's still, that means your physical clocks do not agree with each other. So that's problem number one. But even if you ignore this fundamental issue, so the clock devices people use, they are not perfect. So the clock devices, they are not perfect. Right? So so here I show you a few examples. So they ranges from very cheap devices like the crystal oscillators, where you can find in cheap electronic devices, all the way to very fancy atomic clocks. But whatever clocks you are using, they have this problem with clock drift. That means from over time, your clock runs slower or faster compared to the actual real physical time. Right? So the conclusion is that we can't really rely on physical clock timestamps to order events. So if we cannot use physical time to order events, what can we do? Right? So it turns out there is a very famous work done by Turing Award winner Leslie Lamport back in 1978. Leslie Lamport introduced a notion of happen before relationship. To understand it, so it basically says that in a distributed system where you cannot have a trusted clock source, what you can do is you can still establish some kind of trusted event ordering. Right? And then this ordering is called logical ordering of events, or causal dependencies. Right? So what is causal dependency across different events? Right? So imagine you have a different participants or processes in a distributed system. And then, so I showed it on the slide, where they send messages to each other. Right? Let's say I'm a process P, and then I send a message to process Q. Right? So even though I don't know the exact timing of me sending the message and then process Q receiving the message, but I know for sure that the event of sending the message happened before the event of receiving that message, if you believe in causality. Right? And then based on that, we can build a chain of causality events. And then because there are many causality chains across the entire system, right? So at the end of the day, we actually have what we call a causality graph in a distributed system. And then you don't need to trust any clock source, right? And then so the causality is actually a trusted source of event ordering. And then to able to identify this event ordering by happen before relationship, so Leslie Lamport proposed a new type of clock. This is not physical clock. This is called logical clock. So a logical clock is a simple data structure. And then by using logical clock, and then you can tag logical clock on these events, and then you can basically establish by looking at this clock and infer the happened before or the logical dependency between these events. Right? So logical clock is a very, very powerful tool that motivates a lot of subsequent distributed systems research, and it has been used by a lot of distributed and decentralized protocols. Right? But the problem with traditional logical clock constructs is that it doesn't really work in a Byzantine environment. Right? So the problem is that it is not Byzantine fault tolerant. Right? So if we have adversarial participant in the system, that they can tamper with logical clock, and then they can produce fake logical clocks that can break the causal dependency or causal relationship between the events. Right? So we did some research on this, and then we came up with a novel logical clock structure called verifiable logical clock. Right? So verifiable logical clock leverages, so this is a very interesting or novel application of zero-knowledge proof systems. Right? And we are using one of the more recent developments in the ZK proof field called incrementally verifiable computation, or IVC. Right? IVC, so compared to traditional zero-knowledge proof, which essentially just prove, for example, your smart contract execution. So IVC allow us to have a multi-step computation that can be verified, which is important for logical clock because this is basically events happening in the system that go from one process to another process. Right? So we do need to have this consecutive proof and verification of these messages. Right? Right, so unfortunately, due to time constraint, I'm not going into details of the technique. But if you're interested, definitely happy to talk to you after the talk. Okay, so that's the research idea behind verifiable logical clock. And then so this is actually a pretty powerful construct. We can use VLC to build a lot of interesting and powerful infrastructure for decentralized applications. So here are just a few examples. Right? So we can use verifiable logical clock to build decentralized mutual exclusion, or another way of saying it is a decentralized locking protocols. And then, so if you use Ethereum VM or EVM, right? So traditionally, this infrastructure only gave you the option to have strongly consistent EVM or VMs across different participants. Right? But by using VLC, we were able to provide slightly weaker form kind of consistency levels for these VMs. Right? So we can build causally consistent or eventually consistent data stores or VMs. So the benefit is that they are a lot more performant and they are a lot more scalable than your traditional EVM implementations. And then if your applications are okay with slightly weaker consistency levels, then they can really benefit your applications. And then another application of VLC is if you're building a shared sequencing layer. Right? VLC can naturally help you to scale your shared sequencing infrastructure. Right? So because so our logical clock construct gave you a trusted partial ordering across different events. Right? So if you have shared sequencing layer where you have different transaction blocks from different layer 2s, if they don't have any causal dependency, our VLC can essentially infinitely scale your system by allowing sequencing of these unrelated blocks happened in a scalable way. But we do enforce if you actually have causal dependency between different layer 2s, for example, you do have cross layer 2 communication or transactions, and then we can identify that causal dependency from our logical clock and then make sure, right, okay, make sure that you actually have the ordering guarantees. Okay, so based on these research ideas, we built the Hey2 stack. So Hey2, as I mentioned before, is a communication layer. Right? So we structured in a multi-layer design where you have a messaging layer, a shim layer, and then the application layer. And on top of our Hey2 stack, we also developed a very novel, what we call the Hay2 improvement proposals. Is similar to EIPs, where we are very open source friendly. So we encourage all the open source community to propose protocols and improvements and the new applications on top of Hay2. So we divide our HIP system into different layers, right? So you can have the base layer, which is like the more foundational proposal improvement, or you can have the middle layer, which is more like a middleware, and then you can also propose more application level improvements or proposals. And then we currently have a proof of concept. So all our code are open sourced on GitHub. Right? So we do have the verifiable logical clock, the peer-to-peer communication library, and then some essentially applications built on top of it as demos. Things like social applications and random number generations. If you're interested, feel free to check out our open source code. Okay, and then we are so our Hay2 project currently is at the POC stage. Our plan is to have a test net somewhere Q2 this year. And then our ultimate goal is to have a mainnet launched later this year, by end of this year or early next year. Right? So if you want to know more information about Hay2, feel free to scan the QR code to visit our website. And then please follow us on X. And with that, thank you everyone for your attention.
So next, we'll have Aaron to talk about introducing unbounded science.
The slide deck isn't up. It's just showing the live feed. No worries. There we go. Thanks so much. Hi, everyone. My name is Aaron Malone. I'm the founder of a brand new project that I'm going to reveal from stealth right here today. We've been working on it for the past year, very quietly in the conceptual stage. So now I present to you Unbound Science. Yes. So this became a project that really took over my life. I've been in the crypto space since 2017. I have 6 other startups that I've founded, but this idea entered my head that science really needs to be fixed. And it was because of one of my friends who was getting his PhD, and he was just having so many problems getting his research funded. And all he cares about is cleaning up the ocean. And I said, that's a great idea. Why isn't money flying off the shelves into your hands to clean out all the trash? And he says, well, we got to do this application process, and then there's a bunch of people that need to think it over, and then maybe I can get a little bit of money, but then by that time, I got to use it for rent. And it doesn't actually ever go to the things that need to get fixed in the world. And I said, okay, man, someday I'm going to fix this problem for you. Fast forward 3 years later. Today's that day. So, since then, many other things have become clear in the scientific community that are unfortunately either broken or just not efficient anymore. And what we've realized is there's many, many things that need to be fixed. So we're just going to try and do the best we can and address many things through this new protocol. So today we're going to be talking about the 6 key challenges that we're facing in the decentralized scientific community. We're going to talk about the market size and the opportunity from an investment perspective. We're going to talk about timing the market, because you can have the best idea in the world, but if there's no one out there that cares yet, you're too early. And then we're going to talk a little bit about our team. We're just going to talk about how Unbound Science actually intends to be a revenue-generating company and not just rely on VC capital forever. Very novel in Web3, I know. Then we'll talk about the development roadmap and what powered-up participation really means for everyone in this room who would like to participate in this new platform. All right, so the first thing that we really wanted to address is the fact that we can't trust facts anymore, because the researchers have an agenda and they're paying scientists to create an experiment that proves whatever they want them to prove, as opposed to giving them money to go out and discover what the truth actually is. And because of that happening for hundreds and hundreds of years, we have no idea about the true nature of our reality, or even ourselves for that matter. And how can we build a better world without the assumptions that we rely on being true? In science, it's all about certain assumptions. And if many of our assumptions are wrong or even counterproductive to what we're researching, we're never going to get ahead. So, rather than copying the traditional models like a Kickstarter, where a scientist is going to put out what they want research, what kind of research they want to do, and then donors come in and match directly with them, we're doing donation pools. So the researchers and the donors never actually interact. And the way we're going to start doing this is with 4 pools: one for energy research, one for quantum research, one for air, water, and soil technology, and the other for pollution cleanup. I think these are all 4 general areas that we can all agree needs improvement. And also, there's many other things happening in DeSci that at the time we started planning, I didn't really see anyone focusing on. So like the biomed stuff's already taken care of. We don't want to reinvent the wheel over there. There's plenty of other people doing AI and peer review stuff and publishing. We're not going to do any of that. That's solutions already done by some amazing people that are in this room right now. So we've got these pools, and we're going to be partnering with nonprofit organizations in 100 countries that participate in a program called OECD, which is tax breaks for scientific research. So now, instead of coming out hat in hand asking for money, we're simply telling all these people that have to pay millions of dollars in taxes, do you want to give it to scientific research that makes the world a better place, and you have a voice in where it goes, or to the government? Pretty easy sell. Then we have a security problem. Many of our best and brightest minds throughout history, when they're creating technology that really ruffles the status quo, they're simply either bought out of their IP, which gets stashed on a chain somewhere, in GE's vault, in best case, or in worst case, they're just plain old assassinated. And this is not just stuff happening from the dark ages. This is still happening very much today. From the time I was a teenager, I would hear all these new inventions of these modules that you can put in our cars, and it can run on water, and it would just disappear. Same thing 5 years later, disappears. I think I've rediscovered this invention 4 or 5 different times, and it just disappears along with their inventors. And now that Porsche and Volkswagen are coming out with technology, it'll actually come to reality. That sucks. So we are dedicating everything to protecting scientists' identities, and we're going to be using zero-knowledge proofs in order to do that. So the scientists can optionally choose to remain completely anonymous through the life cycle of their research and time on the platform. What this also does is it allows people that don't fit into academia, the builders, the doers, the people that don't care about writing or following rules, this allows them to play in the same game for the first time. And as I've traveled the world, I found some of those brilliant inventions, things that can cure cancer, things that can provide infinite energy. And these people have survived assassination attempts. And now this has a chance for them to receive money for the things that they can bring to the world that can absolutely change the game for all of us. The panel earlier today talked a lot about blockchain and the amazing things it can do. And the one thing that we're going to be using it for is preservation. We don't ever want to have a situation where the Library of Alexandria burns to the floor and we're back to zero. And we have no idea now where the statues on Easter Island came from or what that civilization was like, or if Atlantis was real and there was really an advanced civilization, if Tartaria was real or if it's just a Twitter meme. I have no idea at this point because we didn't have this technology before. Now we do, and we're going to be settling all the scientific data on multiple chains so it can never be forgotten again for all of human history. And then there's the financing option. The general public has never had a say for what gets brought into their world before. It's really just been this tiny little group of people that cares about science and an even smaller group of people that control it. And I think it's time that that system at least has an alternative. As I've been listening to a lot of talks from DeSci Labs this week, scientific academia sounds a lot like the rap industry, where it's really just gatekept by a few little people with a very prestigious brand and all the control over publishing. And it's very ego-driven and very prestige-driven. And it's the same thing. You keep these people and the things they believe in the most trapped in this little box of writing and publishing, and the revolution never starts. Very clever. Well, we're going to do to science what the creator economy has done for art and music in Web3. But really, the overall mission that really means a lot to me as I've been traveling the world is how unfair the access to technology is because of copyright law. And we believe that access to technology should be a human right, not a copyright. There's no reason that countries that freed themselves 300 years ago from the colonialization of the Industrial Revolution still don't have access to first world technology, either because of trade embargoes or because simply no one cares to share that with them. We're going to throw that on its head. And we're going to be doing that through a distribution marketplace. Anything that's funded through our platform is going to subscribe to a brand new license for open source science. Very much like the GNU license in software, we're going to be putting it out there where the scientists will still own everything. The platform will never own anything, but they have to agree to give it away to the world for free. The scientist is going to make their money in a much smarter way than trying to compete with international businessmen. Through this platform, they will have one-touch agreements for consulting contracts and for emergency engineering deployments. So instead of trying to fight the biggest 100 or 1,000 companies in the world, just work with them. They're going to mass produce your idea faster than you ever could anyway. So we've got some aligned incentives now. Market size and opportunity has never been better. Guys, you are in the right place at the right time. If you're in this room, I don't need to tell you that, so we're going to move on. The graph doesn't really show what's happening there, but basically over the past couple months here, you see these little couple pixels here. This is a giant Google Trends line that has just skyrocketing and hockey sticking up in terms of searches. So that's great. Fortunately, I'm not doing this alone. I'm just one guy who can't even code. But fortunately, I've met a few people that have spent their career in government, their career in building Web3 tech, their career in academia. And we've got an amazing team of well-connected people from all over the world, from all different styles of talent that are going to be able to help really build a lot of big partnerships and bring in a lot of the existing authorities in science, because we don't want to replace them. We want to collaborate. Only when we collaborate as a human species can we really make the world better as fast as possible. So that's the goal here. So yeah, this is how we're going to be funding the platform. Every transaction that comes through the platform, whether it's a donation, a peer review comment, an argument on the internet, which is an infinitely scalable model, it's going to cost a little bit of a token. And if you're in the middle of an argument and you run out of tokens, you better hit that donation button and get some more, because you have to prove you're right. So with that in mind, we've got these tokens that are flowing through the platform, but you're earning these tokens through every action as well. So it's this really great symbiotic economy where the pools are never going to empty. You have a fixed supply, but they're never going to run out because these transactions aren't burning. They're just going back to Treasury, which acts kind of like a cache. So we now have some different groups that are going to be involved here. You have a group of scientists, and they're going to have their own profiles and their own features, their own voting weights and their own voting caps. Because they're the experts in the field, their opinion matters more, and that should be reflected. But also, it shouldn't be the only opinion in the room, so we're going to allow the general public for the first time to have a say. And this is where it really, really comes into play. Because we can't be having 60-page grant applications and a bunch of these published papers that no one can understand. So what we're going to do is we're going to have a game show. It's going to be like America's Got Talent, and the interface for this whole thing is going to look just like YouTube. But it's going to be nothing but scientists up there showing off their products, showing their ideas, filming their research, letting us actually watch them as they're experimenting, live streaming. This is going to make science cool again, and also accessible for the general public in a medium that they can actually digest. And then from there, we'll have a couple seasons a year where we bring in different judges and people and sponsors to actually have everyone come through and vote on what wants to be brought into the world through these donation pools. And there doesn't have to be just one winner. There can be, everyone can win if it's a good enough project. And now the world gets to decide what actually gets created in it. First phase is just the MVP phase. I got a great idea. I need 50 grand to help get it off the ground or whatever it is so I can quit my job and actually focus on what I'm good at. Cool, 50 grand, VCs burn through that shit all the time, no problem. But from there, you come back whenever you're done. Okay, I've got my idea. I proved that it works. Now I need money to really figure out how to build a factory to manufacture this stuff. And I need to figure out how to scale it and get in the hands of every other person around the world who actually needs it. Cool, how much do you need to do that? Great, 3 million, 5 million, whatever. What does the community say they want to spend this pool on? That's up to them. I don't have any control over it. So it's going to work that way. Where's this at in terms of development? We have been working on this conceptually for about a year now. And at the ETH Denver Hackathon, we're building the MVP for this. So on March 2nd, we're actually going to be revealing a skeleton bare bones of this platform, and then spending the next 2 to 3 years building out all the features, and hopefully working with many people in this room that have a great idea on how to break this, because it needs to be tested and battle tested really hard. I want to fail 1,000 times before we finally get this right, so when we release it to the world, it actually works and stays working for a long, long time. So other than just signing up as a general community member, there's a few ways that you can participate here. If you have an organization in traditional science, decentralized science, venture capital, government, whatever it is, there is a special section just for you. And these are called visionary NFTs. And these visionary NFTs give you super user voting power on the platform. Because not just as a scientist have you dedicated your life to it, but you have an entire group that you represent of people who've dedicated their lives and all their resources to advancing science forward. So you're an expert whose opinion really, really matters. And coming with this also includes revenue sharing. Every transaction on the platform that has that fee gets split in half between the Unbound Science Foundation that's used for further development and our visionary NFT partners so they can further their own developments and their own research. Because as I said before, this needs to be a symbiotic relationship, not a black hole. We want to support decentralized science as much as they're supporting us. So, with that in mind, it also comes with a custom integration into your own systems. So you can see all the scientists that you're referring, bringing to the platform, all your employees. You can track them all in your own systems as they're going through this new technology. And so that covered that there. And effort. You know, if you have ideas that have been shot down through your own current existing relationships, bring them over here. And if that may interfere with some contracts or agreements you have, stay anonymous. For the general people, we welcome you to join our DAO. And there's 100,000 memberships available. And these take a share of the fees generated for Unbound Science. So everything going into the Unbound Science Foundation is owned by the membership, and the fees are given there. We're also giving them an airdrop of the total supply of the voting tokens as well for our early contributors. And as I mentioned before, there's going to be a long beta. So we're going to have lots more fun airdrops, NFT collections, beta testing, and many, many things to keep people involved up until it's time to actually launch the platform. So that just about does it. UnboundScience.com is officially live as 20 minutes ago, 30 minutes ago. You can follow us on Twitter, Unbound Science, just about everywhere else as well. So thank you, everyone, for listening and hopefully for joining the community in a little while. We're going to be having a launch party at the Nerd House, I believe, sometime on the 2nd. I still need to confirm. The 1st? Okay, so it'll be the 1st sometime in the evening. We're going to be giving away a computer to whoever has the worst computer there. We're going to be giving away a great condition MacBook to whoever has the worst laptop there. Because as I said, we want technology to spread around. So I'm putting my own computers where my mouth is. And we also have a very special NFT collection that's only for people that have attended the DeSci events this week here at ETH Denver. So thank you very much, everyone. You can find more information on all this stuff at Unbound Science on Twitter as we get more updates out there. And thank you so much for hosting us and allowing us to do our launch here today. Thank you.
Who's on the panel? I think we need Michael, Josh, Jordan, and there's one other person. Who am I missing? Shar. Oh, how can I forget Shar? Yeah, Pi Data. Who here knows Pi Data? Oh, man, we got to talk. Get up here. All right, so this panel is going to be talking about decentralized platforms in science, open science, decentralized science, what have you. And there's the title, Transforming Scientific Collaboration Through Decentralized Platforms. I am Shadi Al-Damadi, as you can clearly see.
Nice beard.
Beautiful hair, full beard. I'm actually Jonathan Starr. I work with several projects in the space, DeSci Labs, GridCoin, the Science Commons Initiative, and NumFocus. But I am not important. We are going to hear from these wonderful panelists about a decentralized platform. So first, maybe y'all, let's just go down the line, introduce yourselves, what you're working on, and why you're talking about decentralized platforms.
Hi, everybody. I'm Joshua. I'm the founder of DeSci World. At DeSci World, we originally were working on community infrastructure for the decentralized science space, and we've recently launched a technical product called Proof of Knowledge, which again is community infrastructure, but more for the dissemination and the identification of user-generated knowledge.
I'm Michael Zargam. I'm the founder of Block Science, and I'm a board member and research director at MetaGov. I work on digital civil infrastructure, and I look at various layers from the technology to the economic protocols to the governance stack, and mainly focus on how to make things more interoperable, interconnected, composable, sort of move away from like silos and lock-ins towards different systems that can talk to each other in a way that we can kind of interface with the tools the way we want to and still talk to each other.
Hello, my name is Shar Qureshi. I'm the founder of Cure. We are a content creation tool for scientists for decentralized science applications. We have our virtual reality demo here today, so I'm happy to give anybody a demo who's interested.
I'm Jordan. I'm the co-founder of SciNet. We're building software to help increase the speed and accuracy of life sciences research.
All right, awesome. So before we get into the questions, quick poll. Who here is very familiar with DeSci? Knows what it is, the tools. All right, so we got some good hands, but we got some people who are new. So I assume everyone who did not raise their hand is hearing about DeSci for kind of the first time. Medium first time. All right, awesome. So let's kick it off maybe. We're talking about decentralized platforms. What is a decentralized platform? What does that mean to you? It's kind of a broad term.
Okay, I'm going to stick with the Web3 blockchain-based decentralized platform because that's kind of what most of us are here building, but there's other answers, I'm sure. A decentralized platform is a platform that is built on a decentralized blockchain or a decentralized protocol, so you can access it from different parts of the world, from anywhere, without permission. And the decentralized aspect means that there is no one single controlling party that dictates whether or not this platform can function or will go down or how it's operating. The idea of a decentralized system is that the participants in the decentralized platform have equal or at least some power in the ownership or the operations of that platform.
Yeah, so I'm going to distinguish platforms from protocols. So I think of platforms in terms of the more the user experience and like logical layer, where I could come into a particular platform, like let's use GitHub as an example, as distinct from a protocol, which is something like Git. And so we can certainly build these using blockchain protocols and platforms enabled by those tools. But the emphasis on the difference between platform and protocol is that at least in an ideal world, we get decentralization in part from having many different platforms interfacing with our protocols. And that separates the like logical connectedness, same schemas, data sharing, openness really, from the different UX patterns that are needed for different contexts. And so I'd really like to emphasize decentralized science as not just developing platforms, but also looking at the way those platforms interface with protocols.
Yeah, decentralized platforms, to me, the platform component is completely focused around collaboration, networking, sharing data, methods, best practices in a community-led fashion, which leads us to the decentralized process. We want a shared responsibility among community and scientists who are extremely critical of their own work, of others' work, to hone that criticism towards establishing community-led best practices and standards in a decentralized format.
So I have a slightly different take on this because we focus on the technical aspect of decentralization. So for us, a decentralized platform is a platform that utilizes decentralizing technology, like blockchain technology. Specifically for us, it's the Internet Computer Protocol, to accomplish something. So because it is built on that platform, we are taking advantage of the value that decentralization can bring to bear for our mission. And in the specific context of life sciences research, for example, which is what we focus on, there's a big difference between traditional collaboration tools and decentralized collaboration tools that we've seen. For Jelani yesterday was talking a lot about how researchers are on Web 0 and Web 1 right now. And for me, Web 0 is a physical lab notebook that they're just writing in. There's almost no ability to collaborate really aside from just having a meeting or a phone call. And Web 1 is like an email. So the decentralized collaborative platform is light years ahead of not just Web 0 and Web 1, but Web 2, to the point that you're having real-time collaboration with other scientists in different parts of the world, in different research fronts, what have you. That's decentralization for us.
Jordan, let's keep going down that. What does that mean? Like if we're giving scientists the tools to jump from Web 1 to Web 3 and collaborate on a whole different level, what does that do to how science gets done?
So this is something that we've looked at a lot because of this aspect of interdisciplinary scientific research is so important. It gets less funding on average than one kind of research that's on one research front, and yet for every new scientific discipline that's brought to bear on a research front, there's a 20% increase in the impact of that research. And so by advancing the ability for researchers to collaborate from different disciplines, different parts of the world, different institutions, you are accelerating the impact of that research by a large factor.
If at any point one of you guys want to respond to anything that's said, just raise your mic up and I'll call on it. Go ahead.
So I just actually want to jump in on this thread because I think there's an area I'm really interested in here. And for context, when I was much younger and didn't have a beard, much less gray in it, I worked in an aerospace materials lab.
I have more gray.
Yeah. So I worked in an aerospace materials lab, and I literally kept a lab notebook. Like, we fabricated shit, put it in the furnace, fired it, brought it in the back, broke it down, tested its material properties, and I was literally, and I kid you not, printing out a spreadsheet from Excel and taping it into my lab notebook. So I'm feeling you here. But so there's a certain amount of limitations on what can and even should be digitized. And so like what I'm kind of looking to poke at with you and with everyone is the way in which these platforms don't wholly consume science. Science will always and should always have aspects that are beyond the reach of the digital systems. And so how do we think about decentralized science broadly enough to incorporate all of that work which actually can't happen online?
I think the important part here is how you're capturing the knowledge that comes from the science that's done in a non-digitized sense, right? There's some things that should be done in a lab, for example, and the results of those can be tracked and recorded and then put onto a ledger, and that's data. But what type of science in particular are you thinking about that should remain off of the digital record? Because what is the learnings, what are the conclusions from that science that can be drawn, the knowledge that can be captured and digitized?
So, I mean, the reason I'm asking this question is because in that experience, there were things that would just like they happened in meat space. And like we're talking about material science research, the materials are never going to be in the computer. And so there's a necessary linkage or reference and referent, and insofar as we're building decentralized science, we actually have to respect the map territory relation here. And I thought that was a really compelling aspect of what you were saying, and I wanted to kind of push the group to examine it.
Shar, go ahead.
Yeah, I think that I ran into this problem, when starting out in DSci, very passionate about it. I was a scientist for 9 years. I thought that this is exactly how scientists should be rewarded, incentivized, because the current system, as we know, is broken. Getting Web 1 or even Web 2 scientists onto Web 3 is quite difficult. There's a lot of factors at play, a lot of headwinds. And so my kind of ethos is that we have to ease them in to the technology, to all of this technology. I think in the earlier panel we were talking about the cryptocurrency and how scientists are scared of it and they don't want to risk their own reputation by recommending a decentralized science platform, which if it does perform negatively, their reputation is on the line, and a scientist's reputation is all they have. And so the maximum value output on the way towards decentralization of science was my ability to try to implement newer technology that provides significant value, like extended reality, and that can also then be, in an eased way, go into a Web3 component. Now, to your point of how do we get the tangible into the computer, this was one way that I believe extended reality through either virtual or mixed reality can bring the material science processes what you should expect to see when you combust these nanoparticles or anything like that. This is one way to try to.
But you'll never truly be able to combine meat space with digital space, and I love the term phraseology here. So I'm curious how the collaboration platforms, maybe we can dive into that differentiation a little more. We were talking about decentralized labs this morning over at iOS and how that's going to be a necessary sort of step in collaboration and development for collaborative research. We need to take labs outside of institutions necessarily and give them access to everyone. So maybe that VR is that bridge, but are there any other thoughts on the differentiation between collaboration platforms and the digital space and in the meat space? Josh, go ahead.
Thanks. Yeah, I think it elegantly pulls together these 2 points, right? Where decentralized science isn't just the digital space of DSci, it's also the collaboration, the organization and coordination of people in a decentralized manner using decentralized platforms and protocols to do science in the real world. Because as you mentioned, the meat space is kind of the most important thing. And in particular in material sciences, but with a lot of different sciences, the impact that it has on the real world is actually what impacts us, and that's what we should ultimately care about. And so having those collaboration opportunities in the real world facilitated by DSci, the distribution of the findings, the distributions of the observations, crowdfunding, co-collating these incentives or these resources so that you can have decentralized lab infrastructure. That's kind of also what DeSci is all about. It's not just the blockchain-based data protocol, it's also the culture of us collaborating in a decentralized manner.
So I'll give an analogy from a previous career. I also am a legal investigator, and I am kind of at the bridge of very young investigators coming into the industry and very tenured investigators coming into the industry. And what I see from the young ones is they want to do all of their work on the computer, and they don't want to go out on the street. They don't want to go talk to people. They don't want to face people. They don't want to do any of that. And the tenured investigators are extremely suspicious of the value that any computer-based investigations can bring. And scientific investigations, I think, probably has a similar kind of paradigm paralysis on behalf of both generations. The assumption that everything can be digital and maybe even should be, and then also the assumption that there are sort of dogmatically things that should not be. And so that was only a little bit of a pokeback. And so the point is that you can't have only one. Even in a decentralized community, people still need to be able to talk to each other.
So it's a little bit of a leap, but so I talked about the experience with the aerospace materials startup I worked at in this lab and kept my notebook. And then I actually did that when I was very young, and I went to college and grad school. My PhD is in control systems engineering in a robotics lab. And the thing about robotics is that it is the quintessential real-world computer system marriage. You need sensors, you need estimators, you need decision-making apparatuses which affect actuators, which affect the literal world, which in turn changes according to its own dynamics and in ways that can't ever be totally captured in the digital system. And then you, yet again, sense or observe the world. It feeds back into the mechanisms through which you make sense of that and estimate the state of the world, through which you then render decisions. And in particular, I worked on decentralized resource allocation problems within this kind of multi-agent robotics paradigm. And so my experience of decentralized protocols and platforms is literally just distributed control systems. And so what you said actually resonates very deeply with me, because I view the actual meat space science as what the control engineers call the plant, the system you are controlling, the, in this case, very distributed meat space system made up of humans doing science in meat space. But insofar as we're developing platforms and protocols, what we're actually doing is the information system that helps coordinate that distributed activity. And so I actually think you hit the nail on the head by saying, yeah, there's some stuff that actually really has to be in the meat space world, and there are other things that really do benefit from being in the digital world, and that the kinds of solutions we should be building are those that make those systems complement each other.
For sure. This is actually kind of a bugaboo that I've had, is don't just do blockchain for blockchain's sake. And it's very exciting. The technology itself is very exciting, but if we are creating solutions just so that they are on the blockchain, that's kind of not really solving anything. So when it has to happen in the real world, great, but what value can blockchain bring to memorialize that, or make it transparent, or make sure it stays there forever so that other people can see it down the road? That's where I think that the blockchain comes into play.
Before Josh goes here, just a shout out to PyData. DeSci is not a new thing. Open source science is not a new thing. These technologies that enable decentralized coordination have existed for a long time and never needed the blockchain. So very good point. If we're going to bring blockchain into it, there better be a damn good reason that we're doing that. Okay, Josh, go ahead.
Thanks. I think it's important to understand a little bit about the capabilities of the blockchain to bring information and data and coordination to science that isn't so obvious at the initial point, right? So blockchain being a data protocol, you have to bring everything back down into the data form. But it's also interesting when it comes to, for example, incentives. Incentives are a really nice way to look at blockchain infrastructure, because it is just data, but it's also directly involved in the human psychology, the behavioral economics of how do you get people to act a certain way and provide a certain value to a certain ecosystem based on an incentive mechanism. And yes, ultimately it's a data transfer. You own this token for this service, but it's really interacting with the meat space, with the mind space, more so because it's directly a psychological incentive. And I wonder if that's something that you have any thoughts on?
Oh, I mean, I agree with you. I think that the the incentive mechanisms that exist that we can see in all kinds of other Web3 applications can be used to encourage good scientific behaviors that sort of counteract a lot of the perverse incentives that researchers have regarding publishing negative results. All of those things we can flip that on the head if we figure out the right economic incentives or reputational incentives or what have you to get them to do things that actually are really good for the world. Negative research or publication of negative results is something that researchers consistently say that they want to see, they want to read it, and those same researchers are the ones who are very hesitant to publish it themselves. So that could be one of those incentive things that we could fix.
So, I mean, I'm gonna step into this discussion about incentives because I deal with a lot of that in my work today with block science, and I think it's important to recognize that the systems that we're intervening in the incentives with blockchains have other incentives. So, for example, the desire not to publish negative results comes in part because there are both sort of normative and institutional forces that work against that. And so our kind of blockchain-based systems, at least the kind of Gen 1 ones, sort of assume that the economic incentives were the only or at least the dominant incentives informing behavior. When we bring it back to this meat-space connection, we're actually looking at the broader institutional framework in which these behaviors are taking place, and you're using these incentives less to drive behavior but potentially to offset these other incentives that are preventing desirable behaviors. And one thing that I think it's really important to acknowledge is that the economic or financial incentives are only good at some things. And actually there's decent research in behavioral economics that you can overwrite or cancel out normative incentives when you introduce financial ones, and that can be good or bad. And so I just kind of want to emphasize that in this meat space versus digital space model, the economics it's an interesting subject.
No doubt.
Down here first.
Go ahead.
Yeah, I think that this sort of highlights the idea of a shift, a paradigmatic, but also a consciousness or a cultural shift of doing science, right? Because if the incentive models are to replace or to sort of overrun the incentives in the institutions that they're based in the countries, the nation states, or the universities, then that's very much a local thing. Right, and so utilizing these incentives as a way to coordinate people on a global scale requires an incentive that is sort of standardized and is able to stand up against the different incentives provided by the different locales. And I feel like this as a concept is going to make scientists have to have a much more of a collective consciousness about what it means to perform science in an ethical manner or a sustainable manner. And yes, it is a very interesting topic, but it is also kind of the defining topic of our entire lives and probably 5 or 6 generations before and 5 or 6 generations afterwards, because we live in an economic system where money is king. And so to be able to understand this relation between money or incentives, monetary incentives, and science and the scientific output, I think is probably going to be the most impactful thing. Yes, distributed systems, yes, decentralized access, but just the ability to incentivize things that mean the most to your system it's going to be so too powerful.
One short aside.
Yeah, I think that incentives. Sorry, Mike. No. Yeah, the incentives are necessary, but at the same time they're not. Right. At some point, financial incentives should be made, and these incentives should make a lot of sense. It should be almost a no-brainer, right? When I saw decentralized science, I mean, a scientist owns their work. They put in years into their publication, into the research. They should be rewarded. I mean, it's as simple as that. There's now an intermediary. Greed in the system is currently in the wrong place. The point of decentralized science is to replace the greed that is in the system from the publication journals, which is $25 billion a year worldwide, into the hands of the scientists. That is the economic incentive that's going to win the day. But to get there and convince everybody and to break societal norms and how things are already done, we need to make it a very short step to it all making sense. And that's by providing something of value that does not totally demolish the current settings of science and how people conduct and publish and share and collaborate, but one step at a time of, hey, this is extremely valuable. We should change how we peer review. We should change how we train. We should change how we think about incentives. And then I think through time, these financial incentives from all of us and everyone in this room will hopefully take hold.
So the one thing I wanted to jump in on is that the existing sort of research world runs on, honestly, like prestige style incentives, and I don't think that that's wholly bad. I think that there's a lot of ways in which incentives are much greater than financial incentives. There's a lot of work that goes into developing expertise, and it can be really helpful to have systems of accreditation and certification and peer review processes, and many of these systems, they're kind of like overgrown or calcified versions of actually very important, arguably very decentralized protocols. And if anything, our implementations aren't very good. They're a little stuck. And so DeSci, for me at least, is about re-implementing some of these things, ideally in an interoperable way that connects with their older implementations, isn't a parallel or a fork, but just like a kind of mutagen that helps with an evolution of this institutional ecology. And I'm just going to note that like things like whether it's an NFT on a blockchain or just a ledger of, historical contributions, et cetera, we can still produce primitives and implementations of existing protocols around, reputation, prestige, and the kinds of functions that underwrite the non-financial incentives. And if we fall into the trap of using financial incentives as our only North Star, which I'm not saying is what you were saying, but it's a thing that happens very for real right now. We lose sight of whether it's the ethical oversights or the various other functions that help guide that scientific research in a direction that's like productive for humans.
I want to just back up that point really quick. So again, going to the fact that, hey, open source has been around for a while. It's been in science for a very long time. There are many people in the space who will actively reject money because they're incentivized by other things. And once they see money enter the system, they think it's polluted and they don't necessarily want to participate in it. So there's a lot of different ways to incentivize research.
Yeah.
We're also getting a little farther away from the topic. So we can continue on incentivization for a little longer, but just a heads up.
I don't mind if you want to switch.
No, go ahead.
Yeah, I think when I say incentives, I do include the plethora of all the different types of incentives. The thing that I think is really important to hone in on and also to admit to ourselves is that a lot of science is dictated by those that do hold the most financial power, right? And so yes, reputation is, and kind of always was, the primary thing for scientists to organize themselves around since the Enlightenment period, is this sort of prestige. But back then, living was a much cheaper and more sustainable thing to do for most people who had like any form of money. If you weren't a serf, you could kind of live a decent life. And so as a scientist now, there's a certain, with inflation increasing all the time, there's a barrier to living a decent life that you have to fulfill before you can then go and fulfill your dreams as a scientist. And so I agree absolutely that reputation, in particular on-chain reputation, is going to be a big thing. And what this reputation can unlock for you in the future, maybe the reputation can unlock you a stipend for rent or for food or such things in certain communities. But the ability to pay the bills is often what incentivizes scientists to do the science that they do, because they need to have that incentive to live. And I think that understanding that the sort of the upper echelons of corporate science and corporate research, military, pharma, etc., they are able to do the science that they wish because they are paying so much. And that's at a certain point, unfortunately, most people have a price. So if you can get to the point where you develop a system where the price is either too large because most of the sort of minimum viable living conditions are met by other means, then people will start to rely probably more so on reputation and the net good for society and other such public goods as this. I think that unless we sort of understand, or unless we sort of like admit to ourselves that the control of financial incentives is what kind of controls and dictates the flow of research, I think that we're going to really struggle to get scientists to change their ways, or to science in general to change its way.
We can go.
Okay, we'll go back
collaboration.
to so the reason incentives almost comes up almost in every conversation about science and DeSci is because it guides everything. It makes humans do what we do. So the decentralized platforms questions, and this has come up a couple times already. If we succeed in creating decentralized platforms that improve coordination and collaboration across the system of science, how does this help scientific societies and communities of scientists become the center of science once more? Open question.
I'm going to jump in. I'm actually going to try to bridge where we were to this question.
Yes, please.
So here's the thing. Like, as an individual scientist, I worked in a lot of environments, but the most recent before founding my own company was a corporate one, and it was great. I got paid exceptionally well, and then I went on and kind of founded my own R&D company and basically aimed to solve the problem that you were describing, the one where I was like, actually, my goal is to put food on my table, pay my rent, I have a family, and to stabilize income for others. And I think that platforms are actually an initial and important part of that, because when the incentives for certain activities are increasingly transparent, or there are new kinds of institutions like DAOs that are funding research, that does unlock the opportunity for new kinds of labs, groups that are like the size of mine, on the order of 24 people. We have ops, we have comms, we have facilities, but not the way that a big company or the way that a large university would. And to platforms, they provide transparency and legibility and allow you to go out and start doing research. But I want to note that emerging kind of Web3 stuff isn't necessarily the only form of decentralized platform. It turns out that public funding works surprisingly similar to DAOs. It's actually a little bit more mature. It's a pain. You need inside information about how granting works if you want to apply from the NSF. But if you actually dig through the weeds of how to get an SBIR, you realize that the meat and potatoes of it is surprisingly similar as getting funding from, let's say, a DAO, with the exception of the fact that it's a more rigorous process. It takes longer, it's more expensive, the upfront costs are higher, but I think it's interesting to look at the way that the emerging, again, decentralized platforms and their treasuries and their efforts to fund public goods, research, et cetera, mirror some of the past ones. And so I'll end that kind of rant by noting that, much like everything else, it seems that crypto is speed running the history of institutions. And so platforms that have incentives and funding for research are, to my knowledge, currently speed running the funding institution development process, and it remains to be seen if they can slingshot past the mature funding institutions that currently offer grants in the U.S. and the EU and elsewhere.
So, for me, the decentralized platform, I do kind of fall into that bad habit probably of thinking about the technological platforms, but whatever kind of decentralized platform materializes, I think the big value is not so much that it disrupts traditional platforms, but that it frees people from being stuck in traditional platforms. And when they become free from that, it allows for things that we can't even really envision right now. Like DAOs are on the forefront currently of that, but you actually have no limits on how you want to apply decentralization in a way that is going to make sense. And I don't know if people are going to like when I say this, but when the market materializes things to happen in these communities, what that means is it can mean anything. And that's why I think the concept of decentralization as far as platforms goes is great, because it frees people from the strictures of traditional platforms and lets them do whatever they want.
Yeah, I think that the most exciting thing about the decentralized platform, the decentralized sort of infrastructure itself, is the interoperability concept. And as a scientist, in the sort of traditional sense, you normally, when you have tenure, for example, or when you have sort of a grant from a specific organization, you can generally get maybe one or two more sort of grants or income from other sources, but generally you're sort of tied into the decision that you've made, this group that you've gone with, this sort of this university that you work with, for example. In a decentralized platform, a decentralized protocol space, as a scientist, you can have a lot more opportunity to, say, spread your wings and dip your foot into many different protocols or many different platforms. And in a decentralized world, these should interoperate. So it puts the individual at the center of the scientific paradigm rather than the institution. Because as an individual, you can be part of 5, 6, 7 institutions as a standard. And then so if you were in Oxford, no longer does Oxford hold your prestige, but you hold your prestige, and maybe 5 or 6 or 7 other universities or institutions hold your prestige. And the interoperability means that it is not the tenure or the institution that holds your weight, but it's actually you as an individual, and you're now sort of an asset, a scarce asset that people want to incentivize to come to theirs. And it doesn't detract away from your prestige to share your prestige with other people. And I think that's the most exciting thing about decentralized science, is it brings the scientist back to the science, to the center.
I'm gonna jump off of what Josh is saying. I think it's really important to understand that the entire point of decentralization is to decouple the scientists, who really are one of the most integral, innovative, and accelerative individuals in a society, right? That U.S., Japan, China, and other countries, these are all powerhouses in R&D because of funding, but also because it's because they have reached a point where scientists are able to thrive so that their society is able to thrive. And so decoupling the scientists from an institution, their university, their pharmaceutical company, their biotech company, and enabling them to take part in a DAO, and I think this is where all science will be moving to very soon. Thanks to all the credit to everyone in this room. But scientists, I think, will be forming DAOs of small groups of scientists. Technology is getting more powerful. AI is getting more powerful. More can be done with less people, less ideas, and even less money. And so the culmination of scientists owning their special gifts, their ability to innovate in society, will eventually lead to the major adoption of decentralized platforms, any platform, because these decentralized platforms are being built for scientists, as resources, as tools for scientists, for growth, for financing, for collaboration, for data transfer. And I think that's when we will see a really large kind of renaissance. And just one more point to what you said, if we keep waiting for cryptocurrency to be the deciding factor in us pivoting over to DeSci and getting scientists over, that means that we're waiting for like some sort of horrible event, to be honest, like
financial collapse,
an absolute collapse where we all have to be dealing in crypto now. No one wants to see that happen, and I certainly don't want to wait for that to happen. And so, I think the most important thing for us to do, and I'll use what I'm doing very selfishly as an example, using XR to ease the path for decentralization, is that is just one technology that will now lead us to that decentralized science world. But I think the other technology that will get us there even faster, and the only reason that AI will get us to decentralized science faster, is because everybody's okay with using AI. They're not scared of it. They know it's high value, just like XR is high value.
Are you kidding?
I'm not
That's a
scared.
good point. Sorry. Can I do something that's non-standard and ask a question? Because I've heard all three of you say something about separating the scientist from the research institution in some way. Not
It's the opposite of that, actually.
Okay, sorry, maybe not you, but you two for sure. And I am very curious about how that even happens, because the universities aren't going to let that go, and corporations aren't going to want to let that go. And so how does that even happen, or why should it happen?
Can I jump on that train actually first? So what I wanted to say in response to him, then we open this up, is that I wanted to push back on individuating scientists, because being a freelancer as a scientist sucks. You don't get the time scales, you don't have access to the capital or the facilities that you need. And so it's one thing to decentralize, but the atoms of the scientific world are not individuals. They're teams, they're labs, they're small groups, potentially smaller than large institutions, but without capital, and I don't mean money necessarily, I mean physical resources. There were expensive furnaces in the aerospace materials lab. There's equipment in the robotics labs that I worked in. That doesn't resolve at the individual level. And so I would say we may need to re-examine what our institutions should look like and maybe bring them down a few notches in scale. There's some benefits to having labs that are smaller or less tied up into big corporations or big academic institutions. But even that is questionable. I'm skeptical of atomizing. I do see benefits to decentralizing without necessarily assuming atomization.
Yeah, I mean, it comes back to your point about the fact that in the decentralized space, in the crypto space, people are speed running towards the institutional space in itself, and I think that's kind of an inevitability in the fact that you'll have decentralized institutions. So yes, you're individualizing the scientists and giving them the ability to choose their own path and to decide where they go and work. But it doesn't mean that you're decentralizing the institutions themselves, as in there will be plants where there's robotics equipment, there will be labs where you can have the materials, you can do all the materials for all of your science, and you can just, as a scientist, with a standardized ledger, with a standardized reputation system, with a standardized decentralized ID, you should, in theory, be able to go and with scientific vigor go and utilize these decentralized institutions. It doesn't necessarily stop the individual scientists from forming a coalition with another bunch of other scientists and benefiting from aggregating funds for expensive equipment. And I don't think it sort of loses the identity of science in itself as this collaborative aspect. It just puts a little bit more power into the individual to go and decide what they want to do. And just to your point, Jordan, a university won't give away a scientist. Yeah, a central bank won't give away global dominance of its currency. It's the same concept. We're fighting a bit of a fight at the end of the day.
I think this is a really, really interesting conversation because, so I don't think scientists should be atomized at all. I would say more laced, right? They're still in teams, right? Just like a group of 4 or 5 developers, software developers, can make a huge, an impactful app. I think a group of 4 or 5 scientists can make a very impactful scientific breakthrough. And that's happening right now. If you look at these bio-DAOs, that Vibe Bio is funding, and not even the Vibe Bio, but also Molecule. These are small groups of scientists who have received funding. They're not doing their own research, though. They're outsourcing it to CROs, right? They're outsourcing it to CDMOs, so they don't need their own labs. And another point that I'd like to bring up, and thank you, Josh, for connecting that, is that I think the future of science is going to be these groups of scientists as DAOs. They can outsource their whatever science they need done through CROs, through CDMOs. Our virtual reality content creation platform is very good at bringing the methods that you want executed in the lab to the CRO, and they will conduct it exactly as you want it done in your lab. Now, to further that point, these bio-DAOs, if they don't choose to go the CRO or outsource route, there should be, and perhaps will be, and already are in the traditional sense, core facilities that you can rent out. There is lab space for rent that you can conduct experimentation in. In fact, I even tried to, far too early, but incorporate lab space for rent in my state of Ohio. I talked to the head of the president of the Bioscience Trade Association in Ohio, and I told him, hey, I think, is there a need for lab space for rent? He said, every 2 weeks, I have a group of scientists ask me if there is state-of-the-art lab space for rent. Scientists want to license themselves. Teams of scientists want to license themselves from these institutions.
Before we go there, we're going to you respond to that, and then if we have any questions in the audience, get ready.
So I was just going to ask you, in the context of these decentralized platforms, the kind of story you were describing about outsourcing kind of brings to mind a question or even a fear of a kind of emergent 2 classes of scientists, those above and below the API there. And I'm not saying that's guaranteed to happen, but it certainly has happened in other platform approaches to economics. I mean, you can look at the way that I'm just take like the Uberization of things happens and tends to create a class above the API and a class below the API. And your kind of statement about this scientific outsourcing rang like with that for me, and I'm curious how you think about it.
Can you clarify above and below the API? I've never heard that before.
The idea is that you have a platform and that there's a kind of class of people consuming it.
Like UberX and then Uber Black.
No.
More like Uber drivers and CEOs.
Uber, or even just like
limousine services.
So no, even like the people who are drivers and the people who are riders. There's plenty of people who may be both, but the idea is that when you platformize things, the nature of the economic class segmentation that can emerge. And I heard, again, like, not that you'd said this, but like a thing that made me think of this with this kind of these scientific DAOs and then them outsourcing. And I was wondering whether you sort of saw the possibility or the risk of a kind of class segregation in science as a result of this platformization.
I think that there will always, I'm going to go on a limb. I mean, there will always be doers and sayers, right? The ones who do, they will go into the lab. But regardless of all of that, I think scientists can't be kind of dichotomized above and below the API, as you said, in this sense, because that's not the general population. What we're looking at is scientists. These are trained, skilled individuals.
Have you met PIs in traditional institutions? Because I'm not making this up. That's what it feels like. And it's part of the reason why so many people break out of traditional institutions.
You know,
because
at this point,
PI ship feels like above the API instead of in the lab.
At this point, I don't even consider traditional PIs in this thought process, because there will be adopters and non-adopters. I don't think it's above and below. It's going to be, either you get it, you want to stay with the traditional way that you've been doing it your whole life, and you've built a reputation that, of course, you're not going to lose your reputation that you've built in the traditional foundation. But the new scientists coming in, they're looking at these traditional scientists who aren't willing to budge, and they're saying, I'm not going to do that. I want money. I don't want reputation.
We're going to... I think the question here is about the creator class you were describing researchers as is the most important creator class that we got, much more than YouTube and media and all that stuff. They're creating the technology that we're all enjoying right now. And it's a matter of, do these decentralized platforms bring in accreditation that enables people to participate in it, or does it close people off? But I'm trying to switch to, if anyone has a question out here, for these people, we have time for one more question. If not, we'll go straight to Jeff. Yeah. Can you just shout?
Yeah, so I have a question. So what's the biggest opportunities that can be solved by the designers today?
This is a great question to end on. Thank you. So we'll go down the line. We started this way, so we'll start with Jordan now.
So the biggest opportunity, are you asking like a financial opportunity, or like what is the biggest thing that needs to be fixed? Or I just want to clarify your question first. And so the biggest for me is science that is done in a lab takes forever to get into the real world. On average, it takes 17 years for life sciences research to go from initial lab beginnings to a real world application. That is, I want the future right now, and I want science to get discoveries to happen in a scale of months, not decades. So that is the biggest thing. Come up with solutions. They don't have to be Web3, but I do believe that blockchain technology is probably the best tech stack to do this, to accelerate that to the point where it doesn't take decades. We get new developments happening all the time, and it's getting into the world where it's benefiting people and the planet faster. That's my biggest opportunity.
Beautiful. Shark?
The biggest opportunity that I see for decentralized science is a new age of scientists and citizen scientists. Because science, decentralized science, just by the name, is supposed to decentralize. It's supposed to spread the understanding and thought process and passion and process of science to everyone. And so I'm very excited about the ability of young people around the world having exposure to science and this new way of conducting science, and that yes, you can become very, very wealthy, you can be very well known, but you can innovate, you can help people's lives. Becoming a healthcare practitioner or an inventor is not the only way that you can contribute to the benefit of society. That's what I'm really excited for, is the future of science.
What's the age cutoff to be a young person?
No. We got to wrap it up. We're out of time. Michael.
So I think for me, the most important thing, the most valuable thing is granular scientific provenance. So just like the way in which we produce the artifacts of our research, even when they are references back to meat space things, being smaller chunks, more codependencies. Think like the way that Git repos are maintained, but now extending beyond digital artifacts like software to papers, to lab notebooks, to basically, again, just making more granular and having stronger provenance on the artifacts of scientific research.
I think the biggest opportunity in DeSci and decentralization in general is the ability to, or right to self-determination. as an individual, you have the ability to learn so much so quickly now with the information overload that we experience, that in just 2 years you could go from an absolute novice to a near, to someone who's very capable of conducting science and research in a particular topic. And we need to lower the barriers that stop people from feeling free to do that. If we can do that, and people have the right to determine their own future in terms of how they express their intellect, and the right to self-actualization, to make money off of that, to make a living off of it, we will probably have an enlightenment period again, like since the Renaissance period, we haven't seen. So, yeah.
I'm just going to add that there is a lot more. Those are 4 perspectives. There is so much low-hanging fruit in fixing science. There's a lot wrong with it, and to fix it, we're going to need almost every primitive in the DeSci space, in the Web3 space. Attestations, decentralized communities, decentralized platforms, new incentives models. There's a lot of opportunity to innovate in the scientific system right now. It's a very fun place with lots of challenges. So if you see these guys, you want to talk to them, there's also a lot of people here who work with different DeSci projects. Maybe they want to raise your hands right now. If you work with a DeSci project, find one of these people, talk to them about what they're building, what problem they're solving, and find a way to get involved with something you're passionate about. So thank you, panelists, for this great conversation.
Thank
everyone.
you. Thanks.
Thanks for hosting.
So next, we will have Jenna from Athena DAO and talk about women's health, research, and overlooked opportunity in the biotech.
All right, so my name is Jenna, and I'm from Athena DAO. And I actually appreciate the last question that was asked, because I'm here to tell you about the most overlooked opportunity in DeSci and in biotech, and that's funding women's health research. Give me 1 second to learn how to use this. Okay. Yeah, so first I'll tell you about me. I am a penguin, but yeah, to tell you more about my background. So basically I'm a molecular biologist by training. I did my PhD at Brandeis University in Massachusetts. And yeah, and so my dissertation was on circular RNA and aging. And it was through the aging piece that really got me thinking about women's health. Women all experience one thing, and that's menopause. It's guaranteed for every single woman. So that got me interested in Athena DAO, which I'll tell you in a moment. My work in RNA led to me being self-taught in bioinformatics. And also, as a grad student in Boston, I needed extra income. So that led me to Web3 in 2020. And I taught myself how to trade. I don't trade anymore, but yeah, that supplemented my stipend. And so I was really excited last year near the end of my PhD when I saw DeSci growing and becoming a thing. I learned about Vita DAO, I learned about Athena DAO, and so it was a no-brainer to join Athena DAO. And so, okay, so yeah, what is our vision? It's to become the leading decentralized global community, driving translational and transformative women's health research. And so basically, our whole premise is the science is first. So we need more data. And so that starts with R&D. The R&D is going to lead to more clinical data. With this clinical data, then startups in women's health space or academic labs will be able to attract more funding. This investment will lead to more therapeutics, and it will lead ultimately to new treatments for women. And so, yeah, so the problem is basically very few, a little amount of money has went into women's health research. This is just from a McKinsey report showing that just 1% of healthcare money is spent on women's health outside of oncology. And yeah, so we're talking about almost $200 billion, and just 1% is going to understand half of the world's population. Yeah, and so basically I just told you that there's this huge funding gap. And then also I alluded to there's this enormous data gap. And this data gap has been driven on a few fronts. So one is that starting in the lab, often female animals were left out of research. And usually the reason was that they complicated the experiment because they're more variable. Which is true, and I can tell you as a researcher, it's very hard to set up these experiments with equal numbers of male animals, equal numbers of female animals. But either way, it has led to a big lack of data. And then on the clinical trial side, women weren't legally required to be included in clinical trials until 1993. And this is still not great even today because recent studies have shown in phase 1 trials there's still underrepresentation of women, and this is not great because phase 1 is assessing the safety and the dosage of a new drug. So later down the road, we find out the drug is not effective in women, and so this is a waste of time and also money. And so basically there's an enormous market gap, and so this is what Athena DAO is addressing. And so many of you, if you've been to DSI talks before, you've probably seen this, a slide similar to this. And so this is just to tell you that between early stage research, which is usually carried out in academic labs and funded by public institutions, and then later in industry where this IP is developed into a product and fueled by private investment. Between these two phases, there's what is referred to as the valley of death. And so where is women's health in this? So we actually haven't even reached the valley of death part because there's still so much discovery and basic research that needs to be done. And I'm still getting used to the delay on the slides. Behind, okay. Yeah, and so why a DAO? So to this crowd, I may not need to convince you why a DAO, but I'll just highlight what I think is the best part about a DAO instead of like a different type of organization, and that's really bringing the community around the researchers. Because maybe there's someone who is interested in women's health, but they're not necessarily a researcher. We do other things like education, and it's just like a great resource for community members, and it also has become a great way to network as well. We have people from all backgrounds in our community. Yeah, and so yeah, the Athena DAO is a solution to addressing this gap in the women's health market. And so basically what we do is we source, fund, govern, and incubate research. We use novel funding mechanisms. So we were launched from BioXYZ, which is powered by Molecule. Molecule is our service provider, so we use IP NFTs to fund the research, and we're exploring even newer mechanisms that Molecule is cooking up now. And so how do we approach the women's health space? So basically we take a cohort-based approach, and we focus on different areas at a time. And so this started with ovarian aging and menopause. And so the ovarian aging and menopause is a lot because our core team came from Vita Dow. Many of us have a background in longevity. And as I mentioned in the beginning, menopause will affect every single woman along with ovarian aging. So this is where we started. Our second round of funding was on endometriosis and PCOS, which these two conditions take historically a long time for women to get diagnosed and have very, very few treatment options. For endometriosis, it can take up to 7 years to get diagnosed. And so now we just launched our call for submissions on gynecologic cancers. So I told you, that oncology is well-funded. It's the most well-funded place in biomedical research. But again, when you look at the gynecologic cancers, they're not seeing this fund, with uterine cancer being receiving the least funds. And then we're also thinking about moonshot projects. So in the summer, we're really excited because we're going to go into deep tech, and we're thinking there of how to do things like get an artificial womb to the market. And so that is really our moonshot, is the artificial womb. And I mentioned we're big on education. So far we have released two public health reports, and we're releasing a third one next month. And so they all follow the theme of the cohort that we are in. And so our next one will be on cancer, and it will come out very soon. And just a closer look at our core team. So Laura McKinney is our founder. She'll be here later this week if any of you want to talk. Ines, Maria, Estefano. I just joined the core team of Athena Dow. Let's see. Yeah, and as I mentioned earlier, we have people from all different backgrounds, even within our science and deal flow team. Like I'm coming from RNA biology. We have others in cardiovascular health, neuroscientists, pharmacologists. So we really have a wide range of people in the Dow. And then the slide before was just to show we have a lot of support from academic institutions and other funders as well. And so, so what have we funded so far? So in our first round, I mentioned we did ovarian aging. The first researcher we funded is Mario Cordero in Spain. And so basically his work studies inflammation in the ovaries, and he's developing small molecules to alleviate this. And if you delay ovarian aging, this could extend fertility and delay menopause. Our second IPNFT actually went to a professor here at the University of Colorado, and actually he's like on fire this year, has a paper out in Science, 2 papers already this year. His lab developed an algorithm to predict the fertility window and timing menopause. He'll be with us on the 1st at the DSI Summit on the 1st, and also we're having a breakfast on March 2nd where he will join us there as well. And while I change the slide, I can also tell you, the first 2 IPNFTs, they went to academic labs, and it's more than just funding them. We are also working on spinning out companies out of those labs as well. But so what is our long-term vision? We plan to be like the OpenAI for women's health research, and so this includes a few things. I mentioned the company spin out. And also, we're in the very early stages of developing a data platform as well. And join our community if you want to learn more. Like I mentioned, we will be around at different events all week. And we're really excited to be here in Colorado and have one of our researchers with us. So Thank you. And if there's time, I'll take any questions. Well, so it depends on which area.
Test. So let's take 5 minutes break, and then we will have another lightning talk. Test. Yeah.
Hey guys, really quick as we enjoy a break. There are a series of deep tech workshops going on this week in DeSci. We've got open state data networks being hacked on tomorrow, along with funding and incentive mechanisms. The following day we have AI in science and fair and semantic publishing. If you want to learn about DeSci on a technical level, come join these workshops. The series is called SciOS. The address is 2601 Walnut Street. They'll be running from 9 a.m. till 4 p.m. both tomorrow and the following day. And then on March 1st, there's also a event at CU at the Jake Jab Center where we're going to have someone from SETI who's doing a really interesting hardware project as a keynote, along with Eric Schultes, who wrote the FAIR paper back in 2016 as a keynote, and Richard Blyden talking about AI along with a bunch of other great speakers. So you're all welcome to join us there as well if you want to learn more about DeSci. Thanks. You can go to scios.tech, SCIOS.tech, to find the address.
Hi guys, so we are having the next lightning talk right now. So welcome Manu from Copernic Science.
Okay, hello, can you hear me? I hope so. Yeah, just skipping, right? Okay, perfect. Hello everyone, my name is Manuel. I'm working with Copernic Space. I'm building open science marketplaces for the space industry. And today I will give you an overview about the stuff that we've been building over the past couple of years, the direction in which we're heading, and how this all falls into place when it comes to DAOs, space DAOs, and how we can all utilize the business models around marketplaces and tap into the hidden markets of space. So yeah, thank you very much for having me, and let's go. So with Copernic Space, we are the pioneer marketplace in the whole decentralized space ecosystem. So we are listing a variety of space assets, sending things up in space, enabling individuals, small and medium-sized businesses to also leverage these opportunities, either for commercial use cases or for further science funding. And here we go. Oh. Okay, so thank you, sir. So yeah, why space? And why all of this is important. It's the whole topic around market making and market creation. So before I actually partnered up with Copernic Space and a good friend of mine, Grant Blaisdell, I was actually working on building IP marketplace for the space industry, because my hypothesis was that we have actually a tech risk, a technology risk in space. Unfortunately, that's not true. So we can send anything up in space. What the space industry is actually lacking is like valid market creation and commercialization potential, so that companies can create a price and an offering and better navigate the whole progress that we see for our future to unfold. So one of our recent successes was that with our own money, we acquired a database on a so-called Firefly lander that will be sent up to the lunar surface end of this year with a SpaceX rocket. So we acquired this database and we enabled individuals, commercial companies ranging from a variety of industries, from luxury to fashion to AI, etc., to have access to the moon, to the lunar economy. So we sold out in the first month. This was a huge success. I will give you a brief overview about some of our examples and also what opportunities lay ahead. So yeah, so this is how it looks like. A sample lunar payload on our platform. People can just open it up, see the price, submit something, get in touch with us, and we put it on the database. One of our friends at Axiom Space actually made a competition, a contest for the first meme on the moon. Sounds fun. It's also fun, right? But what we can do out of it is actually using all the hype, all the PR, all the buzz around to find additional revenue streams and business models for space companies to find faster paths towards profitability. Same with the research projects that are attached to these companies and beyond. Another example is Sophiaverse. So the first AI asset that we sent to the lunar surface, it will stay there for more than 1,000 years. And actually these sentient modules are an upgrade for the current metaverse that they are developing for AI agents. And yeah, check it out. I mean, Sophiaverse is a spin-out from this whole SingularityNet ecosystem. So I'm definitely aligned with this whole idea of having like decentralized AI in space, just for your info. So, and then we have had a variety of other use cases ranging from deep-in companies to DeSci companies, finding additional revenue streams for a thing that we call spacification, so converting traditional digital assets into like real-world space assets. and having an added value to what they are already offering. We had already also had like 2 D-space companies, so blockchain companies that utilize space, or space companies that utilize blockchain, joining our space mission, and a variety of other partners that support us in this journey. So never mind. Some of the use cases range, again, from space arts and this whole spacification process of converting traditional assets into space assets by setting them up, creating digital copies and verifications, and attaching this to the physical assets themselves, going to auction houses and selling this for the 10x, 100x, etc. So we're creating speculation markets so that people can talk about the pricing, think about what is it worth for them, what is the value that they want attached to the idea and to the concept of converting assets to space assets. So, and then we also have like a physical payload in the pipeline where we send like physical objects up, like small diamonds, for example, or seeds, or also like smaller samples. And also everything ranging from satellite imagery to IP and experiments in space. So, yeah, and then we enable a variety of communities to buy and sell and trade the derivatives emerging out of the spacification process. So this is exactly like how then companies can tap into their communities, engage them, and find novel ways for funding. So the roadmap for 2024 pretty much looks like that. We have like a variety of verticals that we are developing. We have like the first and foremost marketplace that we call Spaceables, about tokenized space art, most scalable one, because this is the culture of space, bringing the whole concept around space exploration to the people, winning the hearts and winning the minds. The second one is called Space Smart, where we are listing like the actual real-world space asset. We are there working pretty closely with space companies, listing some of the underlying IP on Space Smart, and enabling then also businesses to do like the traditional B2B transfer of them. Because, yeah, again, space companies are pretty good in everything ranging they are doing with business-to-government contracts, business-to-business contacts, but the whole aspect of like retail and small and medium-sized businesses is just excluded. And what I'm most excited about is this whole topic around research and tech transfer. So mid of this year, we're actually launching our first prototype when it comes to IP tokenization and papers on-chain, enabling research communities all around the globe to fund their research. And that's Copernicus-based research. So pretty much building a marketplace with project creators, with individual contributors, matching them and finding novel opportunities how they can accelerate their scientific progress. And why now? I mean, last year we had the year of open science. NASA and CERN, the biggest research institutions of our time, announced this. And they are actually desperately looking for all the solutions that we are building in decentralized science when it comes to incentive structures, sustainable open source infrastructure, equitable open science, etc. And actually at the NASA Space Apps Challenge, they were also looking for an open science marketplace. So what we can do nowadays is enable as many communities, open science research projects all around the globe, enable them to actually participate in creating their own marketplace. And this is how it looks like. So you literally have like a two-sided marketplace. You have project creators on the one side with their specifications about the project. You have the users of the platform or the contributors on the other hand with their respective profile, and then you're just simply matching them. For the stakeholders, a variety of stakeholders have an interest in doing so. Universities, publishers, bringing their assets to like a broader audience. On the other side, we have researchers and journalists scouting for the next big thing. The research assets that we can actually put on Copernicus Space, especially when it comes to research, there are like two different paths. So one's like regarding open science with academic research papers, the IP, the experiments, the data, etc. And then the hardware, which is like pretty interesting. So this is everything where we are prototyping like real-world hardware. Where we are enabling people to distribute and actually prototype faster than they used to be. and exactly like funnel the money back to where it's needed the most, and showing that something is actually possible, feasible, and then finding a path forward. So, and for this whole topic around scalable tech transfer, I actually created a framework called OSHIP. So this is like linked to open science and hardware intellectual property, where it's like completely around the scalable adoption of the tech transfer about underlying IP. It exactly looks like that. You have two sides, the two sides of the marketplace, where you're creating a consensus between the researcher and the open science or OSHIP creator. And then it's like a straight sharing of the IP. So it's like all public goods. And the more you share, the more access you get to the IP that is emerging out of it. So in this concept here, people are not incentivized to close up, but sharing is caring, actually to open up. And the more they do, the more the benefit. So we are building right now a variety of prototypes, onboarding different research communities for academic papers and patents. We're working there with a lot of companies also in the DeSci ecosystem. So if you want to join us, let me know and we'll find a good workaround here. And now I come back to the actual topic of this talk. So it's not about Copernicus space and marketplaces, but how can we enable DeSci projects, space projects to build up the marketplaces on their own. So I will tell you a little bit about that. So if you compare marketplaces as a business model and this traditional software as a service business model, as we see it right now with the different platforms in DeSci, you have a variety of pros and you have a variety of cons. So if we talk about marketplaces, you have a good way of bringing communities together, engaging them and creating benefit and value also for further commercializing, for example, the research assets. When it comes to DeSci tooling, obviously this is like the unique differentiator when it comes to the functionality, benefit, and what's driving retention to your platform. So my hypothesis now is that it might be a good idea to combine these two. And here we have like the different functionality aspects when it comes to DeSci tooling that we see right now in the markets, starting with like the basic authentication and access rights to, let's say, papers and IP, etc., to like the whole discovery process and better storing and processing the data, to really like peer reviews and IP management, and then down there also the monetization avenues. So what we can do now is not go into like details and figure anything out that you need to make your marketplace a success. But we can at least have like the few points that lower the risk of failure. So what we can now do to conceptualize the creation of open science marketplace globally is first identify your users and define the roles. So think about the project creators, the contributors, the buyers and the sellers. Think about the utility. So why are you doing this? Do you want to, are you a profit maxi? Do you want to get the maximum out of the tech transfer that you are doing for the benefit of society? Or are you really looking on a scalable process of fostering more engagement and pace in scientific discoveries? And then there's the whole application layer, which is like the unique benefactor when it comes to what is driving people to your marketplaces. And there you can be really creative. You can, for example, pull like, you can combine IP management and monetization. You can also combine like collaboration with peer review. So a modular framework where anyone, anywhere can conceptualize the marketplace and then do the work on their own. So building out a prototype, onboarding the groups that you want to see there, and having an iterative process to further move forward. And then it's about the use case. So if you really want to do this, I would also encourage you to choose your weapon. Do you want to fight climate change with synthetic biology? Do you want to sequestrate carbon out of the atmosphere because you believe that these technologies actually create value for our planet Earth? Or do you want to go into space? And now I want to tell you a little bit about the space DAOs, for which these concepts are actually applicable. So we have like a variety of DAOs, and I can give you a brief overview about the history of decentralized space. So a couple of years ago, 6-7 years ago, we had a rise in projects who combined the principles that we had in blockchain technology with space industry applications. Unfortunately, 99% of these projects died. Just less than a handful of projects actually survived. There were like very early concepts around community governance from Space Decentral, from Astroledger, etc. But none of these projects succeeded until we had one of the major use cases and successes in decentralized space by MoonDAO for DAO governance. So they had a successful token launch. There was a lot of PR and buzz around this. And this was like one tipping point where all the people just awake out of their rest and saw like, wow, people wanna contribute as normal citizens, either for citizen science, for the fun of just doing things in space, or really for the further development of scientific progress. And then more and more followed. So we have Space Rocks DAO doing like public goods funding in space. We have like Alpha Per Se working with tokenized bonds for space funding. And also we have Space DAO AI, a close friend of mine, Red Baumgar in Frankfurt, who's actually working pretty closely with the European Space Agency for in-space traffic management and collision predictions in a DAO governance framework. So, and what we can do right now is actually enable these DAOs who utilize like crypto and tokens and DAO governance and all the good things that we have right now, and equip them with the right business models, the commercial infrastructure to actually become, profitable, create value for the community, and then funnel this money back into the ecosystem. So right here on the right side, you can see like everything for resource distribution, grants distribution, ranging from quadratic funding to retroactively rewarding people, etc. And this is how space DAOs can actually utilize marketplaces today. And two proof of concept that I also did were these QF rounds on Gitcoin. It started out with a decentralized science, a bottom-up, community-driven effort to fund scientific projects, May last year. And there we actually had 75,000 in DAI and supported in total 65 projects. So this was like a really good way to further grow the ecosystem. Same with the first D-Space QF round last year in December, where we supported in the same mechanism as a test to identify how many projects are actually interested in utilizing these grant structures for extending the path, the runway a little bit. And this was also pretty successful. We just had 2.5K in funding and matching, really peanuts, but at least there were more than 20 projects utilizing blockchain technology for space. So from my perspective, a success. So, and how to supercharge all of this? So this is like the last vertical that we are building out with Copernic Space. So everything that is linked to DeFi investments into space assets and ventures. For this, for sure, we require a securities license. We are currently in touch to acquire this. And then we can also like enable all the donation and grants and prizes and hackathons so that we have more people really building out useful tools for the space industry, for space science and engineering, and move us forward. So here you can see my good friend and business partner Grant Blaisdell, CEO and co-founder of Copernic Space. That's on the right is Eva, his mother, so it's a family business. They are not here today, but greetings to you all from Grant and Eva. And here's the rest of the team. You can see space industry veterans, tech nerds, and also VCs supporting us in this journey. And yeah, we are raising. So if you're interested in having a space company in your portfolio, let me know. We are always open to support your individual project. If you want to build out, if you want to contribute to the ecosystem, raise money, right? To distribute to like the people around you who are also like needing this the most, and then also supporting you in your journey and growing out of this. So thank you very much. Good.
So let's take several minutes for the breaks, and then we will have a next panel.
Rodrigo. Research. Yep, that's the point. That's why I put it. Yep.
Citizen Science Foundation.
Yeah, so we're gonna, we'll talk about you'll introduce yourself, what's a DAO, and then what are some of the problems in terms of the funding in traditional spaces, how can DAOs and their different permutations fix that, and then just get into like some spicy topics.
Spicy.
About DAOs and funding.
Okay.
To specify.
No shit.
Fucking
No
degenerates.
meme.
You can talk about that as long as it's related to research funding.
Ask a pointed question about the nerd.
Nope. No, you can bring it up. I cannot ask you a pointed question.
Are you a moderator?
What? I am the moderator, but I also have certain responsibilities. You can bring it up though, and I can eat off of it.
I would like to know more.
But I'm just directing.
Right.
You guys talk.
I mean, I wouldn't mention like the name.
You can mention it by name.
I know, but like what I want to say is like about where the governance comes from and more the governing parties. Usually most of the faculties in the center and most like delegations or centrally distributed hierarchical structures. And
Rachel's here. She went. She's talking to John.
decisions are made by players. Basically by those who care the most about the outcome. Instead of making it like those who
I have 4. Wait.
one here.
Oh, where's yeah? Can we turn on the mic for a second, please?
Hello. Rachel and Jenna, please make your way to the stage. Hi, Jenna. Hi, Rachel.
What is going on, everybody?
Hello.
Hello. All right, we're going to kick
Hello.
this off, right? I know it's the end of the day. We're tired. But it's all good because we're going to keep going.
Woo.
So, guys, thank you for staying so late. Thank you for tuning in to panel 3. And now that's us. So, panel 3 is going to be about DAOs, democratizing access to funding and research. Now, the panel that we had previously with John was focused on decentralized platforms and the value proposition, and it devolved into funding. So we're going to talk about funding again. But what I really want to hope we get into is the different structures that exist in DAOs to allow for different kinds of funding to reach research, but in general, how we can leverage communities and distributed networks to then provide incentives towards whatever means you're looking to accomplish. So my name is Jelani. I am one of the executive leads at DeSci World. We are focused on information aggregation and community development. And I'm now going to pass it on to our lovely panelists. Rodrigo, go ahead.
Hey, what's up? My name is Rodrigo. I have a master's degree in marine biology, a specialization in coral reef restoration and functional diversity of fish, particularly. So yeah, I'm here. We have been created a year ago as an experiment because many DAOs initiate in that way as a prototype. It's called Mesa Reef DAO, and it's an initiative that wants to boost and regenerate coral reef conservation efforts in Mesoamerican reefs. So it's quite interesting because we will talk a little bit more about the projects that we have been supported since a year ago. And it's a little effort. I know that I'm in the US. The amount I will talk with you is a little, but it's really interesting because we, in terms of the approach that we have on the field, we need to create and do some assessments. For example, in terms of climate change, bleaching events, in terms of monitoring, So it's like those kind of actions usually support us, and decentralized science mechanisms usually help us a lot to habilitate all those projects. So that's me.
Cool, I like that. So we have a DAO or a collective focused on environmental and ecosystems. Carlos, what about yourself?
My name is Carlos. I originally was a physician. I studied medicine. Then I went into studying distributed systems and eventually landed on coordination research for the most part. I have been exploring different ways individuals can coordinate with each other on chain. We have created the NERD community, which is a post-work collective of individuals who are sort of aligned in that vision of coordinating. And we've done a lot of things. We are part of the DeSci World development team. I helped develop the proof of knowledge system. We have also been participating in on-chain funding, which we have successfully used to create our own local spaces and sort of make our own little network village happen. And through that process, we've learned a lot in ways of communication and ways of coordination. And I think this panel is going to be a great way to explore those things.
Thank you, Carlos. Rachel, go ahead, please.
Awesome. Well, thank you for your introduction. I'm like sitting next to some OGs right here. What is going on, everybody? My name is Rachel. Some of you might know me from my work at Opolis and the University of Ethereum. So I am, DAOs are very close to my heart. I definitely don't come from a scientific background, but I absolutely love DAOs, and it's what I've been working on since I first got into the space. So funny enough, the first DAO I actually worked on was the Sustainable Development DAO. I've also worked, with a little bit with tree gens, if any know Jimmy, Let's Grow DAO. Yeah, so for the University of Ethereum, basically our whole focus is on education, and that pours over into all other areas, right? So by the way, I'd absolutely love to do a workshop on DeSci and, something similar to this as well. So yeah, a little bit about the University of Ethereum. What we're doing is we're working with universities and blockchain clubs from around the world. Vitalik is our honorary president. We work with the Ethereum Foundation and Vitalik, and we're also hosting EdCon in Tokyo this year. So pretty much all about the education, all about the DAOs, and that is why I'm here.
Happy to have you, Rachel. Jenna?
Yeah, so I'm Jenna. If you're just coming in, I'll intro myself again. So I'm a molecular biologist, PhD from Brandeis. I studied longevity. Through longevity, I got into thinking about the differences between men and women. I can tell you a fun fact. Women live longer than men, but most of that time is spent in poor health. And now I'm with the Science and Deal Flow team at Athena DAO, basically funding women's health research, and we want to see new treatments come to market.
Amazing. So we're going to kick it off, and we use the term DAOs, I think, very liberally, right? A DAO, in my opinion, is a collection of individuals that all have a common goal. But that can take a variety of different structures, and this exists pre-Web3. And so since all of you have collectives, groups, DAOs that address different criteria or different impacts, what is your definition of a DAO?
That question is quite interesting because I have been quite involved in terms of coral reef conservation and conservation biology my whole life. I'm like 32 by now. And since 20s, I just got volunteering a lot with communities like NGOs, collectives, in terms of marine science, basically, and how those kind of hierarchies usually interact is quite complex. And even those kind of, there always be centralization in many types of organization. But a DAO is like it's an old school way of organization. It's like a horizontal way of organization in a coordination, with some coordination efforts regarding a common goal. A common goal, basically. There are many DAOs. We're like now on the Cambrian explosion of DAOs. There are DAOs of everything. Even there's the DAO of coffee, man. As a DAO. As a DAO. We just
shout out to us, DAO.
Yeah. So I think that it's an old school way of organization, and usually with an objective. Right. With an objective. Basically, it's that.
I will use the biblical definition of a DAO.
Okay.
wherever Jesus said, wherever 3 people gather in the name of coordination, that's a DAO. Like, and you don't need the blockchain for that. You can have a Telegram group, but only you need to coordinate and have no. Those 3 people, none of them can be the leader. It has to be a horizontal, like Rodrigo said, and I think that's the simplest definition. And through that, we can sort of build upon it and say, okay, which kind of systems can we create to grow this structure into larger and larger and more complex behaviors?
Yeah, I absolutely love this question. So I was actually speaking on the submarine stage at ETH Denver yesterday and talking about this. So I feel like we should really break down the vernacular and jargon of Web3, right? Because is anyone familiar with the curse of knowing? Like when you know something so well, you kind of end up in this bubble, and then talking to other people about it, they're like, what language are you speaking? I've been practicing this with like Lyft and Uber drivers, like trying to break it down to people who aren't familiar with this. So yeah, I actually had an entire slide on my presentation yesterday. Like, what are other ways for us to talk about DAOs? What are other synonyms for DAOs, right? So the first one, this is one that keeps coming top of mind, is digital on-chain cooperative. That's one, right? So I really view DAOs as kind of like cooperative, that's digital and on-chain. And another thing, I'm going to borrow from one of my mentors. Shout out to Sam Harrison if Sam ever watches this. So he says that DAOs share 3 components, right? So shared interest, shared vision, shared responsibility, right? And also some level of financial on-chain activity. So yeah, that's my definition of DAO, shared vision, shared responsibility, and yeah, working towards a common collective goal, as you mentioned.
Cool. So I don't have such a organized definition, but I would say, like, for us, it's really big on the decentralized part, and what I mean by that is, like, we truly have people spread out all across the globe. We're looking at research all over the world. We're thinking about not just the U.S. market. We're thinking about Asia, as many places as possible. So I guess really heavy on the decentralization.
So those are amazing points. I actually want to double click on Rachel's point of a financial component being, in your definition, a critical piece of a DAO.
I mean, yeah, so it's an organization, right? But then again, I see these DAOs, and I've heard different kind of perspectives on this in the space. Like certain people saying it's okay if there's not, the organizational component, but then again, DAO is a decentralized autonomous organization, right? So if you look at, Slockit at the inception of DAO, the initial white paper for DAOs, it says something about it being like a crowdfunding contract or something like that, where individuals can come together and raise funds to accomplish a goal. So the funding element is a part of DAOs in my eyes. But then there's DAOs that spin up who are kind of more like clubs in a Discord, you know what I mean, or a Telegram. So I don't know. It's really up to you to decide. But I would say, organization isn't the name of,
Yeah, like a homeowners association. Technically, it's kind of like a DAO, right? And they do definitely deal with financial imperatives, but a lot of it is governing an asset, so governing something in particular.
I think it has a lot to do with the size of the. It's like the tool has to fit the need. So if you have a group of people that's small enough, usually with social incentives, it's good enough to sort of foster coordination. But if you want to scale up coordination and coordinate thousands and hundreds of parties and nodes over large geographic distances and time, you require to graduate into the blockchain. What I think a lot of DAOs sort of miss is this starting point, and they want to start right at the finish line, where it's like, we're going to make a token, and that token is going to govern the DAO. But if you if you don't have the organizational engine and capacity already set up, that token is going to be kind of like a meaningless governance token that's going to fit the meme, because there is no purpose for that token. But if you have you could create tokens right now and generate a lot of DAOs based on activity that's already there.
Yes.
So it's more about figuring out where's the activity and making a token that actually represents what the DAO wants people to do, because at the end of the day, tokens are just coordination games. So if your DAO is meant to make asados, then you have to make a token that is issued when that happens. Yeah. And that can apply for any number of things. As long as they're provable and fair, people can organize around those ideas.
Totally agree. I actually have a certain abstraction aspect regarding to what is value in a DAO, because value comes in different presentations. Value probably for many people or for many DAOs is knowledge. And that knowledge could be supported in, I don't know, new ways of tokenization of certain aspects of knowledge, for example. Some tickets for publishing, some incentives that could not be necessarily be financial. It could be like a product, for example. It could be an experience, for example. And usually that perspective usually vary depend of the context of your DAO and what are your foundational approach of your DAO. For example, for me, I have seen that many people have been quite aware of conservation efforts, and they prefer to spend time diving, for example, to have a token. And usually that depends on the idiosyncrasy or the level of education of certain people, or I don't know. It's like an evolutionary game theory game with a layer of social interaction, and that with entropy inside of it. And it's quite interesting because there are many retroactive feedbacks that could be used in many ways. It depends on the situation or the state of the certain entity, DAO, in this kind of.
So I know, Carlos, you want to jump in. But in the interest of the topic, we are looking at how DAOs impact funding with regards to research. But I do want to bring up the fact that DAOs themselves are not monolithic. I think we've seen the emergence of different forms of DAOs throughout the DeFi space. In the DeFi space, being a much newer space, a lot of the DAOs are very much focused on funding. And I'm looking forward to see that interweave itself with other applications and other imperatives, other idiosyncrasies that are relevant to the communities that are seeding or participating in that DAO. But to digress a little bit, we do want to talk about research funding. I think, as I mentioned, the panel on decentralized tooling really brought us back to the imperative of needing better ways to fund research, or that funding and incentives, monetary incentives, sit at the core of a lot of things that are, to take a page out of Chris's book, broken in science. And so let's just focus on that a little bit, but I do want to diverge into other things. And so, Jenna, maybe this question can start with you as another expert scientist. In your perspective, what are some of the issues that exist in the funding realms of science, and how potentially can DAOs assuage or relieve some of those pains?
Yeah, so I can answer from the academic side, and then also, I guess, from the private funding side. So on the academic side, I mean, this is like very recent to my memory, but so how does an academic lab get funded? So in the U.S., the biggest funder for biomedical research is the National Institutes of Health. And so basically it's a lot of time spent writing grants. And so depending on the lab, this could be different. In one lab, maybe the students are involved in this grant writing. In other labs, the professor is completely the only one doing it. But either way, and this what I'm getting to also is a different problem in science. Is like there's this toxic environment that happens in many labs. There's just like high pressure to produce a lot of data. And a lot of it comes from the way the funding is, because you're trying to do your thesis, but you also need to think of generating preliminary data for the next grant application. So, and then these applications have timelines, so it all becomes a lot of pressure. And so just essentially a lot of time is like thought about, how do I get this NIH grant? The NIH grants have not adjusted for inflation in, I think, at least a decade. And science is very expensive. So yeah, on the academic side, there's just too much time spent fundraising, writing grants. So from the DAO, just trying to get the money to the researchers much more quickly, having like less strict requirements around the application. The NIH grants in particular are very, very tedious to write. But yeah, that's the academic side. And then on the private investing side, I mean, so from the private side, maybe you don't want to take so many risks because biotech, pharma is already very risky. Some say maybe even more so than crypto, because because you're spending potentially billions of dollars to develop one drug, and this takes it could take up to a decade, and the chance that it gets through all the clinical trials is extremely low. So from the private side, maybe they don't want to look at projects that are more risky. So yeah, from a DAO, we can think as we grow our treasuries and engage with the global crypto market, and yeah, so then we can start thinking about more risky projects like the one I mentioned earlier. Like for us, our moonshot is the artificial womb. So we can start to fund some of those ideas as well.
So essentially, what Athena DAO's position in the funding pipeline is as an intermediary point between the ideology and potential risky project and the pharma venture or the private venture that is, or even the government grant that is maybe or not funding. So you're essentially de-risking access to funding, or you're de-risking the project, which can then be more attractive to.
So I can say, yeah, we focus on early stage translational stuff. And so from the academic side, like you may be familiar with the Valley of Death between academia and industry. A lot of things die. So another thing that we do aside from funding is with the academics that we fund, we work on spinning out companies with them. So we're in the process there. So yeah, so trying to de-risk and to accelerate getting this thing to market.
And then in your instance, the funding is tied to IP.
Right, yeah. Our funding is tied to IP or equity.
Okay. Rachel, I know you said you're not a scientist,
Yeah.
but in the studies of DAOs, there are a variety of different DAOs that deal with monetization and potential ways to direct revenue to places that previously haven't had that. I'd love to hear your opinion.
Yeah, so one project keeps coming to mind. Is anybody familiar with the Constitution DAO?
Yup.
Yes. Yeah, so...
Where's Eric? Go ahead.
Oh, sorry. Yeah, so I was just thinking, like, DAOs are really a borderless, kind of global way for so many different people to come together and fundraise rather quickly. I actually interviewed Adam Miller from MyDAO. Do you know MyDAO?
Yep.
Yeah, so I brought him onto the podcast I was doing through Bankless DAO, Crypto Sapiens.
Yep.
And he used that as a great example of, like, a group of people from around the world that were able to raise an obscene amount of money very quickly to buy the U.S. Constitution. So that's just one example. Then I look at other projects like Nouns DAO, if you know Nouns, who are looking to like fund public goods and like, you know, I feel like Web3 and DAOs really offer us a pathway to fund things in a way that we never had possible before, right? So, you know, Athena DAO is a project also I've been looking into and have been wanting to look more into actually and connect with. So, yeah, I'm really excited to learn more about Athena DAO as well. And yeah, I just see DAOs as a way for us to kind of streamline funding.
I think that what you point out about Constitution, nouns, and a lot of other examples of short-term fundraising is that we got this. Like, we are good at raising money if you have a story. People all over the world will have a viral moment and send it. Yeah. The main issue right now is that once you have these huge treasuries, they kind of have a lot of weight to them in the sense that it's hard to deploy them effectively in the market. And this is a problem that Nouns DAO kind of has sometimes, where they don't know what to fund because they have so much money that they don't know what to do with it. And in that sense, I think that the next few tools for DAOs are the tools that allow them to do sense making as of what they even want in the first place, and research about their wants and needs in order to be able to execute on that.
So you know what, there might be a crossover here on something I'm working on when it comes to like DeSci. So something I'm working on with Nouns actually is getting funding to build wells and increase clean drinking water access in Sierra Leonean villages. So does anybody know the Princess of Sierra Leone, Princess Sarah Culberson? She's a big advocate for bringing more blockchain tech and innovation into Sierra Leone. So we met with her for the University of Ethereum. I brought her onto a workshop, and you know, some conversations later ended up bringing this to Nouns and saying, hey, we want to build a well so we can increase clean drinking water access in Sierra Leone, you know, and I've been talking with the team. We went on Nouncil, and now we're able to actually build a well in the village of Bumpe in Sierra Leone. So that is happening this year.
That's
yeah.
awesome. How much was the total project funding? Because I kind of like wanted to.
So I am asking for $39K for the first well. Now that's like the nonprofit, so Sierra Leone Rising. That's for us to have the boots on the ground, building the well. We also want to allocate some media coverage funding. We want to allocate repairs for the well because, you know, some of these wells, I don't know if anybody knows about like, you know, some of these wells like in Africa and Sierra Leone, these rural regions, the maintenance and repair is a major issue. And only about 2% of the country has access to clean drinking water, which is just really startling to me. So it's just a huge humanitarian issue, and I see Web3 as a pathway to like get something like this funded and actually make a tangible impact.
Right, and to your point, I think if we found new ways to, for example, pre-approve an amount of money to do projects that match a set of goals, so that users can like avoid this process of campaigning and doing. Maybe the campaign is like, hey, do a blanket grant for anyone who wants to do a well or well-related project, and you can use on-chain reputation systems to give the funds to those persons, and then use their trust scores so that they can get more over time.
So kind of like reputation.
Reputation enabling grants from these treasuries, so that maybe a noun votes you in and you have like a stipend you can use for your research, right?
Starting to sound a little like Gitcoin.
Go ahead.
Cool. So yeah, I want to add something regarding to that, because I believe that science needs to be urgently be a public good, because theoretically it was in ancient times. But then, you know, the new ways of economic models just came. I actually agree partially. I don't want to sound dichotomic, you know, two sides, because every side has a story in a certain way. And we need to grasp over the past to see what the past could tell to us. So Joshua Davila talked about science needs to be communist in his book. And that's really interesting, because eventually, yes. But there are so frameworks in our society that we have been created since history, you know, the many ways of capitalism and all those kind of models in terms of the layer of social, political parties. And yeah, science needs to be communist in a way, but with a certain layer of a structure. Yeah, it sounds really radical, yeah. We could debate with this, but eventually we need to create hybrid models with a new perspective or framework of DAOs. In a way that hybrid models with regulation and with decentralization and intermediate paths to thrive if we want to thrive as a new movement in science.
Yeah, and I also think to kind of add on to that is that there's different strata and verticals that exist in science. There are those that are more amenable to crowdsource funding and are more obvious. Let's say, for example, AthenaDAO and IP, that resonates very clearly with people who necessarily want to have a return on investment, right? So essentially in that instance is you provide a crowdsourcing function. In the case of the well, that is not a return on investment, that's a beneficent and altruistic contribution.
We are actually looking to try and make a sustainable long-term plan for that, right? Like make it a more regenerative thing than just like a one-off. Because we're actually thinking like if we just build one well, that's kind of a failure, you know? Like we have the resources where we can maybe create a longer-term system to have a more sustainable approach to this issue. Otherwise, we're just helping one village get water when the entire country is lacking clean drinking water. So that's actually something that we're thinking about at the University of Ethereum in tandem working with Nouns and Sierra Leone Rising. So, yeah, that's something we're thinking about, yeah.
So from that end, I was speaking more from the perspective of the investor. So how do you appeal to more people wanting to donate towards the cause? So for example, Carlos brought up Constitution DAO. That was memeable. And it's very clear in the Web3 space, people are willing to throw a lot of money, especially in a bull market, at memeable ventures. Yours, however, is a truly impactful venture with no, I guess, obvious return on investment for the fundee.
Well, there is one. So we're actually having so the Princess of Sierra Leone, Princess Sarah Culberson, she's actually signed with Disney to make a Disney movie. Disney executives have confirmed they're actually making a movie about her story. She found out she was a princess when she was 28 years old. Really, really crazy story. So anyway, she's confirmed that she's actually going to make a thank you video, like wearing noggles, like thanking the Nouns community. So the whole proposal is like future Disney princess wears noggles and thanks the community for, supporting a good cause. So, I mean, kind of the value to their community is, getting them more exposure and, the media coverage and all the things that go along with that. So it's good for Nouns too. It's a symbiotic thing. Yeah.
Jenna, I'm sure you recognize, and we both know as scientists, that science is not very sexy. And we're unlikely to have a princess of science put on a movie about the contribution of Athena DAO, although that would be very much guaranteed and wanted. In your opinion, what is it that, aside from, is there other frameworks in DAOs that can push people to want to contribute to science via DAO-like infrastructure that isn't necessarily tied to IP?
So you mean as far as like just contributors to the DAO?
Yeah.
So we actually have a wide range of people in the DAO. Like there's one example that comes to mind right now. She doesn't have a scientific background. She has statistics background, so she doesn't have biology background. But anyways, she knows a lot of programming and like there's many. Basically, what I'm getting at is there's many like other jobs in the DAO besides like for us evaluating the research. So she's on our team to build a data platform. We have some people who are like community builders, which is one thing that I love about crypto is because you always have community around a project. So we have people on that end thinking of like new ways to engage the wider community. So there's like essentially I think it depends on how creative you are, and you can propose a project, a contributor project for us, and we will evaluate it. But yeah, so it's like what you want to see in the DAO, and there's also many different types of roles within the DAO.
Can I ask a quick question for her?
By all means.
So could you explain what Athena DAO is, like what the purpose and mission is? Because I've been curious about this and just want to learn more.
Yeah, so short, fund women's health research. Okay. Yeah, and we're really focused on like getting therapeutics to market just because in the past in science, like even at the basic research level, female animals were not in experiments. Women weren't included in many clinical trials until it was mandated by the NIH in 1993. And even today, in early phases of the clinical trials, women aren't equally represented. So basically, it leads to a lot of ineffective treatments. And if you think of some things like endometriosis, it can take 7 years to get diagnosed. And so like these are serious like health conditions that affect a significant part of the population, and they need like real therapeutics that will work for them.
Oh, wow. Thank you.
So I've been operating in the DeSci space for a bit now, and we often talk about how DAOs and DeSci really allow for us to create alternative incentive models for scientists, right, that go directly towards the idea of funding research. Now, the BioDAOs, of which Athena is one, as we mentioned previously, operate at a layer that exists just before commercialization, so it gets you right over that hump. But I think the vast majority of the scientific universe actually exists further, much, much further upstream than that. And so what are some of the, in your opinions, ways that DAOs can reach deeper into the scientific ecosystem or to the scientific space and fund things that are not obviously, commercializable at front, but could potentially lead to that with a little bit more funding at the base level? You want to start?
Yeah, I really would love to start regarding to that kind of topic, because for me it's quite interesting, because I think that many DAOs could have soul, but we need to find that soul, and eventually that soul is with stakeholders. What are the interests of those stakeholders? Yeah, they have necessities. We need to create eventually this horizontal hierarchy, guilds of expertise. And in terms of those kind of guilds of expertise, you should invest your time in creating new ways of models in terms of funding them with certain products, with certain financial incomes about their necessities, about create frameworks regarding to experiences, basically, to fund the things that they really want.
Yeah, so it touches a lot more on like what Rachel's definition of it may not be a monetary incentive backwards, which is what has been powering a lot of the BAO DAOs, but it can be experiential. It could be something that is tied. It could be a patient group for somebody whose family is affected by a certain disease. Like there are other frameworks that you can leverage as a DAO to help fund fundamental research that doesn't have a return. Carlos, I'd love to hear your perspective.
So as someone who's done like research and like large scale studies before, I think most people fail to realize that the blockchain is not only a transactional layer, but it's an information and messaging layer. And specifically for the topic of surveys and knowing what a group of addresses basically desires or wants. For example, we know what the addresses of each nouns are. So we could create like a dApp that allows them to answer a survey through on-chain attestations and proofs that let us know without without any chance for doubt that this is what they want. And we can have perfect data collection and perfect data attribution, and therefore we can start to create these like organizational intelligences that actually allow us to say, hey, we want this done. This is what we desire, and we can fund this to a degree that our treasury allows for.
So 70% of the nouns community cares for reefs or well billing, and so that you spin out a grant that's specifically for that.
Right, and then you can match those wants with other groups that are doing those things, because like I think a lot of the future of on-chain coordination goes like not individual to DAO, which is a lot of, and not DAO to business, but rather DAO to DAO coordination, and saying, okay, here's the treasury, here's what they want, now come and get it. And allowing on-chain communities to self-determine what they want, and other on-chain communities to self-determine that they can give that, allows you to get more organization per dollar than just sitting down like a $300 million treasury. Like this project, like you're mentioning about the wells, cost $39,000. So it means like it's less than 0.1% of the entire treasury, that if you deploy like a meaningful 10% of the nouns treasury, over time it would be a compounding return that really could make some impact. But right now the deployment rates are really low because they cannot find enough people to get what they want, because they don't know what they want.
Rachel, do you want to jump in here?
I'm just taking this all in because you're making a lot of good points. Something I'm thinking about in regards to DAOs, right? The project and the individual. I think incentive alignment is very important for the projects and the individuals that are involved in the DAOs. And I also think you would probably be able to speak on this eloquently as well. Yeah, I'm going to pass it over to you because I'm still processing. Yeah, I'll probably come back to that.
So the question is like, aside from funding, like how do you support scientists more at like basic level? Or
Not aside from funding, still factoring in the funding, but how do you support science that is not ready to be commercialized? So whereas most of the funding that comes from Athena is the idea that, you know, we'll generate this IP, the DAO itself will then be able to license this IP and have a return on investment and grow the treasury. If I'm a part of the DAO, then now I'm also in control of that treasury. But a lot of science does not reach that IPable point, but still needs to be funded for us to get other aspects that reach that point. So how do we drill deeper into the scientific hierarchy of a scientific project's timeline, go early on and fund early stage research? And can DAOs do that?
Yeah, no, and yeah, so that I do, like on a personal level, that is something I think about a lot, because I was in, I did basic research before Athena DAO, and just really briefly, like the field I was in was new within molecular biology, within RNA biology, and faced a lot of scrutiny, and it made it harder to get funding, but the basic research needed to be done. So I do think about that a lot. So as far as like specifically what Athena DAO is doing is like the data platform I'm referring to, we plan for it to be open source, because we want to and we have data agreements with some of the people we've funded, because we do want to make the data accessible and open, and available to other analysis that people want to do as well.
Interesting.
Interesting.
But yeah, so short answer is like immediately. Yeah, we're thinking of things that can get to market, but long term, we do want to support science at the basic level.
Speaking of memes in DSI.
Yeah.
Hey, I want to touch a topic regarding to memes.
Please go.
So I do have a comment I want to mention.
Yeah, no, go
So, this is something kind of important to add on to that, right? I think something in the DSci world that I'm realizing, or just like the world of DAOs in general, social capital cannot be underestimated, right? Building relationships is so important. Like who you know, who you've taken the time to form friendships with, camaraderie with. That stuff is so important when it comes to funding and just knowing the right circles of people to have these conversations with. So something I'll say is that a bridge you build today could lead you to an opportunity tomorrow. So never underestimate the power of social capital.
So I want to synergize on both of your points, right? So you, in terms of a DAO being able to know, or individuals in the DAO wanting to fund up something that they're interested in, and then on your end, scientists or an awareness of what needs to be funded and the development of that social capital to say, listen, I'm something that needs to be funded. Now, a lot of the issue with basic research is that, one, a lot of it is obscure, right? These are all explorations. They're either cutting edge, so nobody really knows about it. Then oftentimes the scientists are so heads down in terms of doing it that they do not market. And I'll say this now, and I've said it many times before, scientists are really, really bad at marketing. Okay? They're terrible. And so in that respect, I think DAOs offer an interesting opportunity, and it may not be a bio-funding DAO or a funding DAO in and of itself, but a collective of individuals that are there to promote the basic awareness of science, to promote what is interesting coming up, and then leveraging that to then reach out to Athena DAO or anybody else to say, hey, this is a cool new thing, let's fund this, or let's gather a bunch of people who might want to fund this.
Yeah, like if you just look at the potential for discovery on chain, because you have a lot of funds, but right now there's no real easy way for me to go and ask one query and say, where should I work tomorrow to make the world the way I want it to? So if I want to maximize for impact, I need to be able to find the people who will get me the funds that I need. And also, I think that we're overestimating the capacity that we have to do research with just like maybe $1,000 for some compute. Like maybe you need a lot less money than what you thought to actually get some insights that can lead you to get the proofs. And we have now micro-publishing and research objects where it's like, hey, do you want to know this? And that's the most important thing. What do you want to know and what do you need to find out? And then we can all like work around, you know? It's like, that's the two parts of the new scientific model.
Totally agree with you, Carlos, in that way, because actually verification is necessary to verify every steps in science using these kind of tools. You know, the decentralized world of these kind of new technologies using blockchain and Web3. So basically, I think that if we create incentives, like many protocols in DeSci have been doing, in terms of, okay, I will support you gradually. Because if we talk evolutionary speaking, if you tend to do things abruptly, usually are big changes. For good, but eventually, in terms of percentages, usually are for bad. And I don't want to be dichotomic or pessimistic in that way, but if we explore complex systems, for example, in terms of modularity, many protocols right now are looking for modularity and are looking for interaction between chains. And eventually, we will not succeed if we not create, eventually, complex models in terms of funding science, using certain attestations, for example, or hypercerts that eventually could boost all those steps that needs new decentralized science models with these kind of new innovations that we have been exploring, many of us, since a couple of years. So that would be a really interesting approach to have, to see how we can interact with all the stakeholders in this kind of horizontal hierarchies groups, DAOs, to achieve and create revenue in every step of these modular or these tiny dots inside the organization. Because if we have a social layer that is healthy, and if we identified those stakeholders that are doing more eventually with certain points or certain incentivized strategies that actually create value, even value, knowledge, since peripatetic societies of the Greek civilization usually use knowledge as an entity and a focal point to scale many actions of human coordination. So I think that we need to identify certain points in this kind of new systems using a new layer of technology to improve and create a new path for human thriveness. You want to see it that way? Or I think that those are my thoughts. And right now we have been exploring in space many quadratic funding mechanisms, retro PGF, quadratic voting, and there are many more. There are many more. I don't want to share projects and give names, but there are like plenty types of mechanisms, like 20 or 25 that could be implemented if we use science for good and create real value with knowledge and support that knowledge in every step of the scientific research. So it's so exciting to see what will happen in probably a few years.
So there are definitely, I mean, out of this conversation, there are definitely different modalities that DAOs can come together to help fund research. And those can be direct, like what Jenna and Athena DAO are doing, and even Opolis with regards to funding wells or its application. University of Ethereum, I'm sorry, in funding wells directly, but you also have things like reducing the barrier or the entropy needed to fund research by providing better research. So coordinating among scientists to then bootstrap really good, rich data that is easier to fund. To Jenna's point, it costs tens of billions of dollars and takes decades to bring something from inception to market, and even somewhere in between that. But if we have better coordination layers and better tooling to demonstrate the level of richness of knowledge to help push that knowledge forward, maybe it costs less. So maybe DAOs have a direct, but also a cost recovery or cost saving or cost bring down aspect to them as well.
Yeah, and I can already tell you that if a DAO offered like just like survey tech, like just saying, I will survey your population and make an identity solution. So we have the identity solution, we have the domain,
Shadi.
And we tell people just connect with your wallet, prove you're you, and answer these questions, and you have perfect data recovery. Because half of my job in this type of research was like just figuring out how each of the data sources got it wrong in like their data entry from text forms to an Excel file to a database to the process where now we could have direct like data to compute and not even sharing the private data and then just paying incentives back for sharing it. So these structures, you just go to someone who does surveys and tell them, first we need to demonstrate this because no one has even tried to demonstrate like on-chain surveys at a scale. But once you show that the cost per survey is like 10 times less than the cost of surveying like the population, then that's the business case makes itself because they're already spending this money to know these things.
So what are the major impeding aspects to this then? But what is the major thing impeding this adoption?
Basically, no one has structured it and made the math of saying, okay, what if we could survey every individual? For example, WorldCoin has a data set of 3.5 million people. 3.5 million people have already proven their identity on chain, geolocated, and we know where they are. So we could just ask for them, hey, do you want to share some data? We'll give you an incentive. And the friction of giving $1 to 3.5 million people is way less, and we have proofs of that with airdrops. So ask Uniswap, how much was the cost of distributing tokens to however many people you distributed to, and you'll find that it's like 100 times less than if you try to do it through like Stripe, because you can't.
Yeah. So those are limitations or potential limitations in terms of application and operations. But when we're talking about science, we actually have to leave the digital space and go to the meat space, as Michael highlighted before. And in the meat space, we have boundaries that allow us to play, right? So whether that be jurisdictional, national, consideration, ethics, all these kind of things come into play. And so when you're talking about a decentralized organization of people distributed around the world that are all funding or can be funding particular types of research, one consideration that comes to mind is who's to say that research is ethical? And who's to say those that, so internal to the DAO itself, it's the DAO that gets to vet what gets researched. But what happens if you have eugenics DAO? Or burn babies DAO? Or whatever, right?
So,
what are some of those considerations?
So one of the things...
Spicy!
It's a great question. No, it is a great question. One thing I want... So continuing with the spice, one of the things that surprises me the most about on-chain data is that there's hardly any XXX rated data. There's no porn on-chain, okay, guys? I said the P word. The point is that why isn't it there? Like, our human incentive throughout the internet was to basically, there's even a rule for it, right? We all know how it works. But the point is that the blockchain has this nature of being so since what you do is public, and when you support something, you're basically sending a message to the rest of the network saying, hey, I support this and that and this and that. Then, like, by having sent, like, it out in the open, the worst of it, at least, will not happen with as much strength as the good things. Because, for example, if you try to make gun DAO, like just to give everyone a gun, you will have a bigger DAO that's anti-gun DAO because there's more people for that. So do you want to pick the team of those who are going to be like for violence and for all these things, or the group of people who actually oppose that? And the blockchain has this nature of like healing, in the sense of the data that you put on chain is not only there for you, but for everyone else to see. So you have to be kind of cognizant of what you do on chain, and those systems allow us to make better decisions with our collective money.
So I don't necessarily agree with that, but I'd love to see, Rachel, your perspective.
Oh, I was just, I thought what you were saying is interesting. It's kind of like having things permanently on chain. It's kind of like creating a checks and balance system, right, for the community to see into it. But I'm curious why you don't agree with that.
Because not everything is on chain. So you can see things like transactions and what, but you can obscure that, one, and you can create dummies. So you can have a DAO that is, oh, I'm funding, Heavenly Research DAO, right? All I know is transactions are coming and leaving it. You don't have to put where the data is going. You don't know who's at the end of it. And even when the money gets there, who's to say that it stays there and doesn't go somewhere else? So I think there are considerations when it comes to DAOs in terms of funding. Like Uniswap and on-chain stuff is very easy because you're right, it's all trackable, but it's dealing with currencies, which are not the end of it, right? We're talking about things that exist that bridge the gap between digital and meat space. So in addition, something else to consider is if, say for example, there are two people in Athena DAO that are from different countries that are not friendly with each other, right? And they're both funding research. What is the implications of national security in that instance?
Well, so for us, I mean, yeah, I'll answer that first and then go to the ethical point also. So we do this like as a group, like decide on the funding, and we fund one thing at a time. It goes through a review process. It goes to a molecule for additional review. It goes to other senior reviewers external to the DAO. But yeah, people aren't like one person isn't saying I want to put 100K here and another person puts 100K there. Like it's a group decision on that part. So, but yeah, I do want to get to the ethical part. And what I want to get to is like research in the lab or biohacking, because I've been seeing this more and more. So I will say, like for us at Athena DAO, pretty much everything that we're dealing with has gone through some level of review. Like, so if it's an academic lab, they work with vertebrate animals. There's like regulation around what they can or cannot do in the lab. If something is already in clinical trials, like there's already been some level of review there. But I do see like more and more conversations, and especially between like in DeSci and around biohacking. And so that's not something that we are dealing with at Athena DAO. And on a personal level, I think it's up to the person. I mean, the biggest example that comes to mind is Brian Johnson in longevity. If that's what you want to do with your money and your life, then I think that's okay. And I think at least he's making it available. All his data are like mostly available to everyone to see. So I think that's a personal decision, but that's not something that we're funding right now.
So we're coming to the end of our space, and I think we've touched upon a lot of different pillars and different considerations that exist with DAO, those that are more technical, those that are more human-centric, those that are more practical and pragmatic. And I think I really like to go back to the original panel that talks about how do we bridge the digital to the meat space. I think the meat space and that conversation needs to be one of the running themes that exists in DeSci in terms of what is the practical application of what we're trying to do and how do we actually achieve it in a way that is holistic, ideally ethical, and also effective in the long run across a variety of verticals that exist in science. Science itself is not monolithic. There are different varieties of science, and how do we address that, and can DAOs address that? Now, with all that being said, to close out the space, I'd love to kind of hear from all of you, what is your envisionment of what DAOs will be in the future relative to your own specific impact? It doesn't have to be research, it could be anything. I want to know what your future perspective of DAOs are. Rodrigo, go first.
I think that DAOs offer us a new way of congregation and coordination in terms of sociocultural approaches to mitigate many problems that we have as a humanity. You know, and as a whole, because we're animals, basically. We're animals, we're mammals. And eventually we have necessities. We have been creating those necessities in terms of our sociocultural context. And that's why our wide variety of DAOs in many regions. And that's why it depends on the idiosyncrasy. And it depends on us if you want to join a DAO or if we want to coordinate for good to growth as beings, or it depends on our philosophy of life. I think that it's quite open, and I really, at least for me, I really love biodiversity. I respect many ways of expression, human expression. I think that science is one of the ultimate creative human expressions that we have in a methodical way. And science have been doing a lot of things since history of humanity. It's quite redundant, yes, but I really quite involved in natural history, so yeah, it's quite interesting how we will evolve in few years.
Carlos?
So the nerd delegation has this saying that there is no real difference between learning, work, and play. And my vision of the future is a world where we can play the games that we choose and learn things as we go along, but never stop working hard to get to our goals. Because those are three things that, if you look at them together, they're all just research. And what I would like from the future is for more, like literally for everyone in the world to see themselves as a researcher of the things they like, and a connoisseur of the things that they love. And by sharing that and experiencing those things all the time, they can create value to keep doing it. Because all people want is to keep doing the things they love. And if you can share why you love that, you've created some value that should be rewarded to you as a node of the network. Because that's like the intrinsic human value, right?
Very nice. Rachel, love to hear yours.
Yeah, so, oh man, I envision the future of DAOs as a more democratic way for us to show up and work collectively towards a common goal. And I'm going to take it back to ancient Athens for a moment. If anybody knows Cleisthenes, the father of democracy, you know, there were iterations of democracy that didn't work, and that was a very tumultuous time in ancient Athens. So I think with DAOs, we're going to kind of see the same thing unfolding, you know, with iterations that don't work, and that's totally okay, right? Kind of like the scientific method, right? Like you find things that don't work to get to the thing that does work. So I think that's totally fine that certain things in DAOs aren't working because we are progressing towards a more democratic future, I believe. And yeah.
Well said.
And one last thing I'll say about DeSci and getting scientific funding. I think scientists and people working in DeSci need to be loud about the things that matter. I know you said that it's not like marketing isn't a strong suit there. So just be loud about the things that matter.
Yes.
That's the last thing I'll say.
Agreed. I double-click that.
I agree with that also. Yeah. I'll answer on two sides. So one, in the future, the BioDAOs, I think, will be, or not, I think they will be the largest funders of research. And I say that because, like, look how much volume, the number of transactions every day on Ethereum alone. I mean, even in the bear market, it's in the tens of millions of dollars. So we just need to redirect that into science. And we've seen early on that people in the broader crypto community are interested. So yeah, one is the BioDAOs will be the largest funders, and there will be more BioDAOs than just the ones that exist today. And on the other end, because of blockchain and other things that everyone is working on, to Jelani's point earlier, we will see science become more efficient. So yeah, and this could speed up this timeline. It could make things get to market much faster. People will actually see results.
Amazing. Thank you for being on this panel. Give them a round of applause.
Thank you all for coming.
Thanks.
Next up, we have Cass. First, we have a picture, so hold your horses. Thank you, Vesta. Where Martina at? Martina! Hey, don't, hey.
It's a negative proof. You have to prove a negative. First, I want. DAOs. These are DAOs for good.
Okay.
Thank you, Martina. Casper, you're next. Come up on stage. No, cut his mic. I'm not making him say nothing.
Awesome. Thank you. Damn, awesome. Perfect. Casper. Nice. Okay. Awesome. Okay, perfect. Thank you. Will they see me or will they see the slides? Okay, and me or just my voice in the slides? Okay, perfect. Awesome. So are we ready to go? Yeah? Awesome. So hello everybody. For those of you who don't know me, my name is Casper, and I'm the founder of a startup called AminoChain. And what we are doing is building the world's first decentralized biobank. So you guys may or may not have heard about decentralized biobanking before, but today I'm going to introduce you into a little bit more of the basic concepts thereof and demonstrate the true power of what decentralized biobanking can be and all the things that it can achieve. Just going to make sure this works. Awesome. Okay. So, just to start things off, show of hands of people in the room, who's heard of a biobank before? Yeah, bunch of folks. Bunch of different people have. Okay. So, just to start off with, we get a whole bunch of different types of biobanks out there, right? You get biobanks that house diseased samples, you get blood banks, you get sperm banks, egg banks, plasma banks, and so on. And we might start with the basic definition of what a biobank is. A biobank is a really big fridge full of donated human samples, right? And these biobanks are fantastic because they can catalog different diseases and standardize research output. And so they kind of operate at the intersection of clinical care, research, and informatics. And they've been growing in immense popularity from the 90s until today. Coupled with an abundance of genomic data, these biobanks are now essentially powerhouses of precision medicine, right? So biobanks are amazing. We have around 10,000 in the States right now, and that number just keeps growing. So even though biobanks are really fantastic, they have a number of problems. The first thing is that your average biobank will only use 10 to 15% of the samples that they have in their inventory. And a biobank of 50,000 samples represents roughly $40 million worth of sunk cost in human material that isn't being distributed and isn't being used in the labs. So if you backlog that from the 90s until today, the kind of picture that we have is, by a very conservative estimate, 68 million samples across the United States that aren't being used. And that's $1 billion worth of scientific material that's lying dormant and not being distributed towards researchers. The second thing that's very sort of integral towards biobanks is this notion of trust and mistrust, right? Because obviously what's full of, what's inside the biobank is, you know, human samples. And to get them into that biobank, you need to have consent and you need to have a specific procedure to get those samples. And right now, the experience for the human research subject, the patient, is totally a one-way street, right? A researcher will go up to them and say, can we have your sample? They'll say, yes, sign a piece of paper, take it, and they'll never see each other again, right? The researchers will then take those samples and they'll distribute them among scientists and academics, and they use these samples to publish papers and to create drugs, and all of the money and value essentially circulates between these centralized entities, right? And the biobanks are the ones that are, you know, they have the onus of bringing the ethical, legal, and social implications back to the donor. So they have to very manually tell the donor what's going on with their samples, what their samples are contributing to. And increasingly since the 90s until today, this is becoming a bigger and bigger issue because the patients really aren't informed at all about what's happening with their material. So that means that we have, jump back. That means that we have this picture of consent rates being incredibly low, right? At major institutions, consent rates are as low as 25%. And the people that don't donate their samples are the ones that represent the biggest unmet medical needs, right? So we don't have a lot of samples from marginalized communities and patients of color, and that is no secret. We all totally know that, right? So that skews everything downstream within scientific research, from clinical trial diversity to statistically diverse data sets and allogeneic donations. So mistrust within scientific research is a particularly huge issue within biobanking. So if we just stop there for a second and take a little bit of a zoom out, I find this really fascinating as like an interdisciplinary notion of what biobanks are and what blockchain is. And if you look at this map right here of all the different biobanks in the world, just a few to represent them, what you can kind of see is that these are isolated entities full of one-of-a-kind immutable objects that have distributed ownership and a very certain provenance. And all of these biobanks are battling with issues of governance, custodianship, and trust. And all of those buzzwords are directly relevant to blockchains, right? So if you zoom out and look at these, what I see is a decentralized node network that doesn't have a protocol to connect it. So that is what decentralized biobanking is. And a little bit about, you know, what we're building with AminoChain. Let me jump forward. Just, yeah, this is great. This one's perfect. Thanks. Yeah, so the solution is essentially a system in which every biobank that exists out there can download a software package called the node. I mean, we call it the Amino node, but this could be any blockchain out there, right? So this node software isn't, you know, a validated node, doesn't validate layer 1 transactions. It's more like a chain link node, right? It's something that the biobanks run on their servers. It has a wallet inside of it, and it abstracts away everything Web3 related and connects to their lab inventory management systems, their databases, data capture softwares, EMRs, whatever else they use at the biobank. Every biobank that runs a node in the network will be connected to all of the other ones that also run a node in the network, such that any biobank can have whitelisted access to view the samples and inventories of others within the network. They can streamline licensing of samples and exchange via material transfer agreements. And folks can far easily simulate what you call industry collaborations, right? Working with pharma companies and biotechs to improve cost recovery and sample distribution. The best part of this whole network is that the donor can track where their sample goes and how it's used. And anytime there's an exchange of money for these samples, the donor can get a royalty fee paid back to them. So that sounds pretty awesome, but in reality, all it is a way to create a bunch of NFTs out of donated samples and then an NFT marketplace that issues royalties back to the people that donated the samples, right? So what is the real big vision with decentralized biobanking? And in my mind, what we're working towards is something called a biobanking L2 app chain, right? The distributed node architecture run by these different biobanks, clinical sites, and pharma companies can power so much more than a decentralized biosample marketplace and data marketplace. Imagine a world in which a researcher holds a de-identified sample and they think there's something interesting about it. It has an HLA polymorphism, right? So maybe this is a predisposition towards an autoimmune disease, but I have no idea. And I've actually found 5 samples, all with the same polymorphism. Imagine if there were a ZK bridge back to the medical records of the donor that donated that sample, and the researcher had a way to query for yes-no answers on the phenotypes developed or the treatment protocols of those patients. And so whilst maintaining privacy-preserving standards and HIPAA regulations, you can bring real-world data and real-world evidence straight to the bench side to drastically inform the research output for these researchers. Take a level on top of that. Imagine a pharma company is holding 100 samples. They all have the same polymorphism, and they've actually created a drug to treat this polymorphism or to any hotspot mutation. Now they can send a message back to these 100 people that donated these samples to ask them if they want to enroll into a clinical trial. You streamline that whole process 10x as well, right? All through the distributed node architecture. Take a level on top of that. Imagine a system in which biobanks that produce organoids or cell lines, and they're powerhouses of data that are replacing animal models within testing. If they could stake their data and you had a federated learning model such that everybody could contribute data towards AI algorithms that are used within clinical diagnostics, and everybody that contributed to those data sets gets equally reimbursed, right? So what we're talking about is a fully autonomous, decentralized system that has transparency and benefit sharing at the very heart of it. And that, in my mind, is what we would call a circular biobanking operating system with a whole bunch of killer dApps that can be built on top. So to wrap this up, I think the main idea here, what's super interesting, is that we're kind of taking this notion of trust provided by blockchains, and we're applying it to an industry in which trust has been a really big issue for a super long time. So trust within blockchains, we all understand how that works, but trust, this is a silly equation I came up with, but I kind of like it. Like, trust within biomedical research, in my mind, is engagement and accountability over time. So how do you get engagement? You first of all make things personalized, right? If I can personally see what happens with my samples and data, I can see that it's used for good purposes, not nefarious purposes. It's used to help people of my particular religious or ethnic background. I'm going to feel more inclined to partake in the research experience. On top of that, you have tokens, right? Using those ways to incentivize engagement is a fantastic thing as well. So how do you get accountability? You show that your donated samples and data are used exactly how they say they're going to be used. You can track where it goes between the different distributed node system, and therefore you feel that anybody that uses it in the wrong way will be kicked out of the network immediately. So that's how you keep people accountable. And if you do these two things over time, then you'll really build a trustful system for folks to participate within life sciences research. So I recently came across this one quote, which is the one thing that I kind of want to leave you guys on. And I find it super fascinating. We'll quickly read it. The idea is that too great a concern for rationality essentially debars many people from having the power of choice and narrows further the available options from amongst which to choose. Too great a concern with liberty, by contrast, leaves everyone hostage to unwisdom. And I also had to read it a bunch of times before I fully understood it, but the idea is that we are facing this sort of trade-off between rationality and liberty. And I find that really fascinating because rationality is the world that we live in today. The researchers say, we are the scientists, we know what's best, so we should house this data in these samples, and we should define the ethical frameworks because we are the ones that make a living out of this, and we're the real professionals. Liberty is what we're trying to achieve with blockchain. We're trying to give everybody the right to access their data, to self-custodially store it. And ultimately, that's fantastic because we need more ethical systems. But if you give too much liberty into the systems as they exist right now, you will have everybody essentially dynamically saying no to things that they don't understand. And that will hold us hostage to unwisdom and slow down scientific output unnecessarily. So what we need to do as folks working in DeSci is really find the sweet spot of what is rationality and what is liberty, and what tools and platforms can we build to hit the exact intersection for the next 20 to 40 to 100 years to come. So yeah, thank you all very much.
So we will having the last session, the Design Pro Show, and I'm introducing Danette. She will be our first speaker for this session.
Have you ever wondered what the world would look like in 10, 20, or 30 years? Have you ever wanted to be transported into the future to see what it's like? Well, today you will be. My name is Danette, and I'll be your guide into the DSci portal. I want to thank our friends at ORSI for inviting us here today so that we can take you on a journey into the future. Before we get started, I want to set the set and setting. We're going to go to a time when decentralized science platforms and protocols are fully operational. So imagine this in your mind's eye as we're talking, because it's said that you have to see it to be it. So I believe it's important for us in the DSci movement to imagine and see what we're building towards. After we resolve the problems of science, the immediate problems that we have in science, what are we building after that? What do we want to see beyond that? To help us see what's possible, we have 3 other guides that I will introduce to you today. Our first guide will be Dr. Christopher Hill, who in his future self will be with the Prometheus ARC, Autonomous Research Collective, and he will show us what that looks like. Chris.
All right, how do I connect this?
They have your slides. So, Chris?
I made some last minute changes.
Oh.
Let's do it.
Well, he has slides.
Can I connect my laptop? Or is that?
We're ready for his slides.
Oh. Oh, I have to use those slides. Okay. All right. I'm not sure what was inside here, but I'll give this a go. So hello, everyone. I'm Chris, one of the co-founders of DSci Labs, and today we will talk about visions for a DSci future. The Vor singularity. This is the coordination device of science, and this is the object that is broken. It is a hyperstructure, it is hyper-coordinated. It's a multi-layered defense system to access the incentive layer of research. Outside, there's a protocol, the Vor protocol, with its own sets of norms and systems and APIs you must interface with its own metrics, like the journal impact factor, citation trackings. If you go 1 layer in, you have the Vor validators. They're also known as publishers. What do publishers do? Well, they take in your paper, conduct peer review, put their stamp of approval on it, and have it indexed. What does indexing mean? Well, that's the heart of the Vor singularity. Indexing is done by the so-called Vor oracles. This is the Web of Science, Scopus, these databases that essentially determine what is real science and what is a blog. It is a fundamentally vital structure. In its absence, we are left with chaos. There are no viable alternatives out there.
And as we know, it suffers from a number of great limitations. Hyper-consolidation. In the past, in the 2000, 43% of the market was controlled by the top 10 publishers. Today, 2023, 73% of the market is controlled by the top 10 publishers. It suffers from commoditization. What used to be, journals used to be newsletters for scientific communities, things you should pay attention to. Well, now that process has turned into alienating production lines to stack our CVs and boost the rankings of our institutions. And security breaches. You might have seen the many scandals around purchasing authorship, purchasing citations, or the types of pirates that happen, right? There's all sorts of spaceships circulating this stellar structure. And these spaceships are constantly attacking the Vor singularity, trying to get fraudulent papers from paper mills accepted, such that these fraudulent authors that have paid off corrupt agents within that system can access the incentive layer of science. So how do we escape the Vor singularity? We have to unlock meta-science space travel. What do we mean by that? That means expanding the space of coordination models for communities to enable scientific societies to publish research objects that contain more than PDFs. The Vor singularity just only cares about manuscripts, your data, your code, all these other artifacts that make science reproducible and verifiable are treated as second-class citizens. They just don't matter. We need to change that by providing new primitives for scientific societies to be able to create research objects that are rich, incrementally upgradable, and so on and so forth. And we want these to be on an open state repository so that any type of client application can connect to a shared data layer. We have to expand the space of curation. We have to give communities a way to break down the peer review function and its nebulous, in its incredible clarity. We need to unbundle, reconfigure, extend the scope of curation and give them the ability to attest to research objects. And expand community sovereignty. The unpaid nature of peer review today is not a fatality, it's a design choice of the system. And there's many other types of coordination model where we could return sovereignty to communities to decide on the flow of value and on the models by which they want to curate science. I'm aware I haven't talked about the future yet. I'm just setting the stage. So we need to take off to meta-science space. And that is one of the core missions of DSI. We want to be able to find new coordination mechanisms and to empower these scientific communities to self-organize to create better, more reproducible, more reliable knowledge. Okay. So chapter 1, the first thing we need to do as we are going out there to explore meta-science space is gathering allies on the way. We can't operate in a vacuum. One of our first missions is understanding who out there within that vast array of infrastructure providers and systems and platforms and TradSci could benefit from some of the boons and technology that DSI brings. This is the way we escape the Vor singularity. And if we go and we start traveling in close proximity of the Vor singularity, we're going to find some uncanny allies. So let's explore low orbit meta-science space. And what will we find there? So we're going to take these escape vessels that are moving through meta-science space and forge some alliances. We find a mysterious planet with a strange colony, landing our arcs, and we recognize familiar names. I call this first colony the Kive Federation. The Kive Federation have been at the forefront of the preprint revolution. When the ARCs encountered the Kive Federation, they started to trade technology. The Kive Federation brought in a model which was revolutionary at the time. The idea that we should first publish and then filter, rather than first filter and then publish. But the Chi Federation, for all their success, they suffer from two problems. The first is that they need indicators of trust so that their preprints can actually convey useful information regarding their reliability. And so the ARCs traded the technology. They gave to the Chi Federation the technology of attestations so that they could link to their platforms these indicators of trust, going from openness of the data to the reproducibility of the results, to the commercialization potential of these discoveries. The Chi Federation had another problem in which these trade relations became really useful. They could only support PDFs. That was a problem. And what the ARCs traded with the Chi Federation was the ability to store data, to store code, to store a variety of artifacts onto these systems to create much richer and much more interactive scientific artifacts. And so the ARCs made other discoveries along the way after having made these treaties with the Chi Federation. The ORCID Alliance. ORCID is an identity provider for researchers. It's very popular and it's very useful because it provides a unified login system. Now the folks here might say, well, we don't want that. That is a centralized identity solution. To this I'll retort that we need to build the bridges. And ORCID provides us useful resistance against Sybil attack. And we provide ORCID, again, engaging in trading relationships, the ability to have much richer researcher profiles where attestations such as the openness of the data, the reproducibility of the results, awards for having created reproducible pieces of research that follow best practices in open science could be mirrored to the profiles of researchers and then shared with their academic institution in a completely legitimate fashion. Yeah. One of the greatest unlock of this process is that through intense trade negotiations and treaties, DeSci managed to become an open infrastructure provider. Standing at the same level as Crossref and DataCite and these registration agencies that are responsible for minting DOIs. That unlock gave us an unprecedented reach in the scientific community. Oh, we went a bit further in low orbit space and we discovered more stalwart allies. The Fair Data Stewards. These are people that have been at the forefront of thinking about how scientific data should be published, should be made reusable, should be made interoperable, should be made essentially much more useful than it currently is sitting in these silos and databases that can't even talk to each other. And so we brought to the Fair Data Steward the technology of DPID, decentralized persistent identifiers that were built from the ground up to power the fair data principles. The Fair Data Stewards greatly benefited from that technology and pushed it across their networks. And in exchange, again, engaging in trading relationship, the DeSci movement became legitimate. We started having uptake with institutional repositories, with people that are at the forefront of thinking about data. Why? Because we have a technological edge by using decentralized web technologies. And so we were able to establish technological tech transfer with the Fair Steward Alliance. And so this laid the basis of this united infrastructure that gave us the capability to create bridges with the existing system, to create legitimacy with repositories and institutions, provided us the capability to have identity solutions and all sorts of fairly valuable connection points with the existing system of science. And that let us explore deeper into meta-science space. So let's dive deep. Let's think about the incredible things that were discovered by these arcs as they moved towards new points of coordination and uncovered incredible technology. Now, these arcs, of course, have very varied trajectories. Some of them crashed into oblivion, afflicted by scandals worse than Raddigate. Others, however, were able to flourish, and on the way, they made incredible discoveries. And let me give you a glimpse of a few of these. The first thing that was discovered was plural curation. It stands to be questioned why it is one PDF, one journal. That is an artifact of the time where we were monetizing copyright. It makes no sense today to have a one-to-one mapping. What if we could create plural curation? That means one research object, multiple scientific communities can reach out there, can validate these attributes, can think and bring perspectives that are novel to existing research communities. The unlock of the one-to-many curation relationship was one of the first discoveries that enabled a much richer interdisciplinary and multi-perspective research in that ecosystem, and it fostered discoveries. What else did we find? New markets for validation. It turned out the hypothesis that the only people willing to pay for scientifically accurate and solid data were libraries from universities turned out to be a false hypothesis. As it turned out, the moment you introduced attributes that could be verified about reproducibility, about the quality and trustworthiness of data, about commercialization potential, it opened new markets. All of a sudden, biotech startups started sponsoring validation because they didn't want to spend millions of dollars replicating studies that don't work. So they started having a natural incentive to contribute to a more pluralistic ecosystem of scientific validation. And the unlock of new market enabled DeSci to grow beyond the traditional payers for scientifically accurate information. And that was a major unlock, which enabled new markets to be uncovered. My favorite, composable authorship. Authorship tables are one of the most contentious things in science. It is the nexus of so many conflicts. It is the thing from which credit flows. Oh, I'm first author. No, I'm shared first author. No, I'm second author. Why am I second author? No, I want to be third author. Right? All of these bickering around authorship could be systematized away if we had ways to transparently credit contributions. And composable authorship is this notion that you could have a kid from India out of nothing who's just passionate about research and science, and he takes a research object published on the DeSci network and he forks it. And he admires this group that's been working on a topic that is close to his heart. And he made a pull request. And he said, hey, I've added a Jupyter notebook, put in all your equations, and I made your work more useful for other. On the other side, prestigious group, from Harvard somewhere, saw the pull request and said, damn, that kid's smart. Actually, that's really useful. Now I have a Jupyter notebook with my results. I have better curated data. I'll accept the pull request. And that kid, coming from nowhere, broke institutional boundaries. He became an author and a recognized contributor of this research object. And imagine having the ability to lower the barriers to participating to the scientific credit table. That was the beginning of a real revolution. Decentralized societies, the abilities for ARCs to self-organize, to reward their peer reviewers. You had some ARCs that said, well, we'll pay peer reviewers. And that started to be popular Because right now, today, if I send my work to a journal, I'll pay, $2,500 for the privilege of being featured on their webpage after they've orchestrated the peer review process from my peers that have been unpaid. No longer. All of a sudden, any fees that were generated through the validation process could be returned to the communities that had generated that value in the first place. And so think about the trade. What do you prefer? A well-formatted PDF? $2,500? Your community doing all this labor for free, orchestrated by a publisher? Or a community that actually returned value to the people that contributed to scientific validation, paying them? And that was so important, because today scientists live in miserable financial conditions. It's impossible as a PI to rise the salaries and the stipends of your doctoral students. And all of a sudden, these decentralized societies gave that capability to those PIs to say, hey, guys, here's a way you can have a stipend by participating in scientific validation, uplifting the lives of scientists worldwide by rechanneling the value of scientific curation to the people that did the work. Chapter 3, the Vor Rebellion. Okay, I'm not sure about my slides at this point. The fever dream of these scientific societies stuck in Vor validation farms, farming their free laborers, oppressing them in these structures, in these alienating production line. All of a sudden, DSI had unlocked meta-scientific space travel and had taken back incredible technologies and brought these technologies back to these scientists who, of course, were at the start incredibly skeptical and then afraid. But slowly, the spell began to break and curiosity started to rise. And editorial boards all around the world started thinking, you know what? Well, I heard my colleague, they resigned from Elsevier and they went to Oxford University Press. Well, what they got out of it was an APC discount of $500. It's just more of the same. And DSI, I have all these new capabilities. I can uplift the living conditions of my communities. I can create these rich interoperable research objects with attestations. I can change how things are done. And at that moment, the spell began to lift. These editorial boards started to rebel. They started to abandon the validator farms of the Vor validators, building arcs and getting ready for meta-science space travel. And so, that was a vision for a much more plural future. A future that returns welfare to scientific communities. A future that creates value for the scientific record by making it more reliable, more robust, pluralistically curated, that enabled people from all over the world, citizen scientists with an interest in science, to participate as authors with people all around the globe in top institutions, showing their merit and their talent, forming new networks that enable talent to bubble up and be channeled in the scientific discovery process. And so, that was my talk, that was my vision for a DSI future. I hope you enjoyed it. Thank you. Thank you. That's why I wasn't sure about the slides.
Okay, our next guide into the future, Dr. Jelani Clark, will take us, whose future self is part of the Decentralized Biobanking Initiative. So he's going to tell us stories from that future.
I guarantee you it's not going to be as good as Chris's. By any way, shape, or form. Big hand out to Chris. Chris, that was an amazing story. Okay. I don't even really know what to start. Chris touched upon so many different aspects of the DeSci space. Got my picture back, please? Thank you. The story is not about me. I think it reflects me. So the question was, build yourself in the future. So this is Jelani 2045. Clearly not great yet. I think the future of DeSci, and I'm going to sit down. I think the future of DeSci encompasses a lot of interesting narratives. Chris's space narrative as a voyage into what the probabilistic future is, the narration, the concept of the vor, and all these cool things, I think are a really good representation of what we hope DeSci can bring. I have two major pillars that to myself I think are very important, and he touched upon. And that is the ability to open up the scientific contribution or contribution to the scientific record of knowledge to all peoples and persons around the world. My hope is that by 2045, if not sooner, all persons and people who have questions and are interested in seeking the answers to those questions have the opportunity to do so in a way that allows them to free up their mind. I think the current paradigms obviously do not allow for that. But my hope is, and one of the biggest issues that I think that we have in in traditional science, is the concept of brain drain. There's no reason why a burgeoning scientific industry, whether it be space travel, biomedical sciences, archaeology, anthropology, or anything, can't exist anywhere on the planet where people exist. My goal, my hope, for everything that we do here is that a child, in Chris's case, a child in India, who is interested in contributing to the record of science. Or another instance, somebody living in an Amazon forest who wants to study and understand how their culturally relevant holistic medicine can impact diseases in different frameworks, shouldn't be able to participate in how science gets done and what kind of science gets done. In the same realm, I imagine a world of interconnected infrastructure in science where no one person or no one stakeholder is left out. Danette introduced me as the instance of biobanking. I think biobanking is a fantastic framework that we can look at this with. In the biobanking industry, when you give your samples, you have no idea where they go. You don't know who uses them. You don't know what kind of impact yields from them. And I hope that whether it be tissue samples, ideas, dreams, creativity, DeSci provides us with the opportunity to be able to feed impact back to us so we can understand how exactly we're building the days of the future. And so that's pretty much all I got. But I hope that, wait, I'm not finished yet. I said pretty much, okay? Not all finished. Well, my goal and what I hope that we have is a mosaic representation. Not this is me in the future. But I want to see what everybody is going to look like in the future. I hope to hear what everybody's future definition of DeSci is, because I think what DeSci's future is the mosaic representation of all of our wants, needs, and thoughts. And if we can achieve these, which we can, but only if we work together, I think the future is going to be fantastic. It's going to be a lot of hurdles. It's going to be a lot of uphill battles. The representation of the vor and its equivalencies in a variety of different places in science is not insignificant. It's not trivial. I think we do have a lot of things that we need to tackle. But if we remember, and I think the theme for this DeSci Denver or DeSci Summit is interoperability. If we can weave everything that we're doing together, Sina stuck in his virtual world, others doing other kinds of things, I think we can make this work and we can make a much brighter future than what we have today. Now I'm done. Thank you.
Thank you, Jelani. Okay. For our final guide today, we have Jonathan Starr, whose future self should show up here any second. It's your typical squirrel hybrid.
Oh, man. I'm so proud of this. That's what I prepped. That's about it. Okay. Imagine a future where DeSci does not exist. That exists. Oh, man. No. Okay. All right, imagine a future where DeSci does not exist. The decentralized web does not exist. It's science and it's the web. Along this journey, banks no longer exist. We are our own banks. Along that journey, institutions, they still exist, but not in the same way. They stopped trying to survive. They started trying to add value to society. They started playing a different game, a different fight, a fight to make our lives better. So these institutions that currently are the Vor complex learned that they could maintain their power not by trying to maintain their power, just by making our lives a little bit easier, making the world a better, more equitable, more ecologically sound place to live in. For that thing. Now imagine along this journey those institutions that still exist, the Natures, the Elsevieres, the JP Morgans, who are no longer banks as we know them, they were joined by the ARCs, the decentralized societies, now, the communities that decided they had a mission they wanted to fight for, they wanted to contribute to society themselves, they wanted to learn and add to the record of knowledge, the scientific record that we've got. They are now just as powerful as the Vor syndicate that we knew of 50 years ago. Because of that, these societies don't need to continue to exist. It's not just that they stopped playing the game to survive. They're okay with dying. They know that there is an endpoint to everything. Perhaps at this point, 50 years in the future, we don't die biologically, but our systems die, our structures die, and are replaced every other week, every other day. There's no reason that we need to have the same economic system, the same industrial system, the same caste system for more than an hour. It could shift based on the context of our needs as a society. So perhaps one of these societies created an economic system that wasn't rooted in debt, the thing that these banks used to enslave the world. It was rooted in scientific output. The more science you create, the more knowledge that can be used by society, translated into a product that makes the world a better place, the more money you get from the protocol that mints that money. From there, because the money is distributed to scientists and people adding value to life, it goes to other things that those people think would be valuable. So that debt system that creates an IOU when that dollar is generated to basically enslave the person that is given that IOU is instead a research object that has created a new way to desalinate the oceans. And now we live in a world where the more science you do, the more knowledge you create, the more money you get. You can be greedy, and by being greedy, you make the world a better place for everyone. So imagine, I hope you imagine when you're dreaming that thing, because that would be a beautiful future. That's all I got.
Okay, we Well, we've returned now. That was our journey through the portal. Thank you to our guides. Thank you for traveling with us. And for your, if you collect POAPs, you are welcome to come up and collect this POAP saying that you went through the DeSci portal. Thank you very much. Have a great night.
So that would be our last session, and thank you guys for being here today, and also staying till that late. Yes, and also join our science community, and yeah, And you guys feel free to stay in here for a while.
Thank you, Eva, for putting this all together and your team. Thank you.
And please feel free to stay here for a while, networking, and we're closing around like 8:30 or something. And enjoy yourself, and also have some water left and snacks left, and you guys can take all this.